Let me join through the laptop to share you the tudes. Still 7. 1 is a new student, right? It's about a 6. Still 20 students have to come. Right, it's 7:30. Give me a couple of minutes. I'll quickly share the tude in the chat box for online students. So for online students, for the moment, since you don't have the printed tude with you, it's actually a very small tude. Hari, it's a very small tude. So I'll share the tude in the chat box. You can download it from there. Very small tutor, because this lesson is a very small lesson. Right, so the notes that we are discussing in the class, you can take it in a writing book for the moment, and once you receive the tudes, you will be receiving the tudes with the inequalities and modulus functions, and then partial fractions and logarithms, small tude, and the vectors tude. Okay, that's it in one post. In another post, you will receive the trigonometry, polynomials, and quadratics tude, and also the system of coplanar forces. Okay, because I don't have to resend the system of coplanar forces tude once again. I start the lesson because December last week I starting that one. No, so for today, you can download the tude from the chat box, and when we are discussing, right, you can write it down. Even the physical class students, if you want, you can write down the things in a paper. Actually, I didn't ask you to bring a, what do you call, a book for this, right? Because if you take a book, maximum we need somewhere around 20 pages or 30 pages only for this lesson. But if you want to buy a book, you can take a 40 pages book or 80 pages book, okay, to maintain both inequalities and partial fractions lesson. Inequalities, partial fraction, ඊට පස්සේ logarithms, ඔය set එක මේක පුතක ලියන්න පුළුවන්. Right, so today just take the note wherever you want, and then you can maintain one single book for inequalities and modulus functions, partial fractions, logarithms, those are small lessons. Okay. Right, තාම 9යි 11යි. Still 15 to 16 students should come. Right, we'll start the session. Others can go through the recordings now. Right, tude for online students, Huda, I have given you the PDF tude. So for the sake of online students, to help them, I will read the topics and I will give you the notes as well. Okay, so those who have the tude, those who have the printed tude, no problem. Those who don't have the printed tude, වැඩ කරගන්න. Right, so modulus functions and inequalities, one of the easiest and smallest lesson that you have in your pure mathematics syllabus. Pure math syllabus, we have lots of lessons. The number of lessons are higher in pure maths, but the lessons are very small. Only big lesson that you get in pure maths is trigonometry. Trigonometry very important. Local lesson in pure mathematics you are going to get is like a very big lesson with the calculus 2 parts only, differentiation and integration together. It will be somewhere around 2 to 3 months, both lessons together. 3 months again, right? In differentiation and integration, right? Otherwise, after that, the biggest lesson, as a biggest lesson, you can consider this one, what do you call, complex numbers, right? Complex numbers is the next biggest lesson that you can consider as a biggest lesson. And in pure mathematics, most difficult lesson kila gattod, the difficult lesson is also complex numbers only. Otherwise, all the other lessons are like, with the practice you can do. Complex numbers is the only lesson that you have to use your deep intellectual thinking to understand the question and do it, right? But for 27 A-level batch, okay, 27 A-level batch, I'll be discussing complex numbers lesson parallelly with the other lessons, but parallelly while I'm doing the calculus parts. Next February or March, I'll be discussing complex numbers lesson with you, because I need to cover up that early to practice questions. Because before you go to the exam, you should know that I can do all 17 questions kila hitagana gihilla. It then only you have to decide to do which 5 questions you are going to do in essay paper. Don't fix your mind. I'm going to do obviously these 5 essay questions, not all this, not these 2 questions kila. Don't fix your mind and go. Unfortunately, the 5 questions that you are being ready is difficult. Now you will not get the full marks. So you have to practice for all 7 essay questions, which means the entire syllabus. So we need to cover up the syllabus early for that. So 26 A-level batch, 4 months ahead the exam, and for 27 A-level batch, 6 to 7 months ahead the exam, will be covering up the syllabus. Right, pure syllabus next July with your giver lagi. Pure math syllabus. Applied because we need to take some time to discuss applied properly. Right. So currently we have started vectors for yesterday's batch, and Saturday online batch and Monday physical batch. I'll be starting vectors this week. Hare. Okay. Inequalities and modulus functions. Write the first topic. Definition of inequalities. Definition of inequalities. So these are basic theoretical aspects. Lokusine, pattalesi. Just listen and understand. Online students, since you don't have the printed tute with you, just write the topic and take the notes with me. Okay, there is no any deep thinking to understand this. So definition of inequality says that, let's say there are 2 numbers, A and B. These are real numbers from the set of real numbers. What are real numbers? All positive integers, all negative integers, 0, all rational fractions, all irrational fractions, everything. Together, if you take, those are real numbers. So A and B can be any real number. So this notation you studied in grade 9. A and B are elements of set of real numbers. These are real numbers. The first case says that if A is bigger than B, if the number A is a value greater than B, it can happen if and only if. This notation, we say that if you don't know the idea of this notation, you can write it down. If and only if. So this notation, we use it to write the if and only if. Remember, if and only if means this can exist only if the other condition exists. What is it? If A minus B is greater than 0 only. Makes sense, no? If 5 is greater than 3, it can happen only 5 minus 3 is greater than 0. So you can ask me why the hell this we have to take it as a definition. Already no. 5 is greater than 3 can 5 minus 3 obviously a positive answer. No? You can question me that now. But the person who introduced this one introduced it as a theorem, as a definition. You are not questioning this one from Newton. No? Take the simple principle in Newton's first law. What that person says? If there is an object, that object doesn't move until you push it. It should be, it's introduced as a Newton theory. We have an object. This object doesn't move until you push that. If it is at rest, if you are not giving a push to that one, it's not going to move. Otherwise, if it is in a a uniform speed, if you are not giving a force to stop or accelerate its motion, it's not going to change its motion. That's what the Newton's first theorem says, right? Then एक common sense එකක් නේ. For us, it's going to be a common sense now, but in the beginning of science, in the evolution of science, මේවා ලොකු දේවල්, right? ඇත්තටම ලොකු දේවල් තමයි. We study those things very simply in your syllabus, right? This one also we have to understand as an axiom, right? These definitions are axioms. Based on these axioms only, complicated theories are developed, right? So in university level, when it comes to physical sciences, if you are studying mathematics, right, University of Sri Jayawardenapura Maths Department එකකින් උගන්වනවා axioms 11ක්, right? University of Columbus teaches them somewhere around 13 axioms. Actually, both the number of axioms are same, because in our 11 axioms, in one of the axioms subpart විදිහට තව දෙකක් උගන්වනවා. So altogether, however, may 12 to 13 axioms are there when it comes to algebra. You can like may set and logics theory, right? So like that, we discuss different types of axioms. Axioms means what? Without any proof, you have to believe that it is true. In the beginning of universe, මේ ලෝකෙ පැවැත්ම පටන් ගනිද්දි those things were there as it is, by defined by the god of mathematics or defined by the almighty. A decide කරපු දේවල්. So this one is a definition. If a number is greater than another number, it can happen only if the difference of the numbers is positive. What kind of a difference? The greater number minus the smaller number is positive. Greater number minus the smaller number is positive, right? This is the one that led us to believe a bigger number minus a smaller number is a positive number. You didn't know that, okay? The someone who told you to do so like that, someone mentioned that 5 minus 3 is plus 2. If you subtract a smaller number from a bigger number, answer is plus. You studied from grade 1. If you question that lecturer, why is it like that? Can't it be a negative number? They don't have an answer. Why is that? It coming from an axiom. This is the place. If two numbers are, if one number is greater than another number, the difference of the numbers is greater. What kind of a difference? Bigger number minus the smaller number. If this exists, then this one also exists. That's one thing. Now, if a number is smaller than the other number, this can exist if and only if, right? If and only if this one minus this one, smaller number minus the bigger number is negative. Smaller number minus the bigger number is negative. And ඕක තමයි පුතා definition of inequalities කියලා කියන්නේ. This is the definition of inequalities. Based on this one, knowingly or unknowingly, we are going to solve calculation based on this one only. This is the core of every other calculation that we are about to study and that you have studied since grade 1. In future, whatever the maths you are going to study, in the maths that you have studied since grade 1, everything based on these applications, right? Okay, so quickly write this down and write the subtopic representing an inequality on the number line. Representing an inequality on the number line. Representing an inequality on the number line. Online students write ඕලියන්න. Right. So let's say A and B are two real numbers. A and B are two real numbers, right? So now if I take A and B be two real numbers, here so yeah, from the set of real numbers, if you select any number, that number has its own dedicated point on the number line. Well, a කැමති number එකක්, you can take any number you like. You can take any number you like. Every single number has its own dedicated point. And that point can be found comparing to another number. So let's say when I take two numbers A and B, I can discuss three cases: case 1, case 2, and case 3. I don't know where the 0 is. Okay. So let's take case 1, case 2, case 3. The case 1 is where A is greater than B. The case 2 is where A is equals to B. The case 3 is where A is less than B. Right? These are numbers. So on the number line, we already know that on the real numbers line, from left to right, okay, right, left to right, we know that values increase. Then what's the opposite? Right to left, the values decrease. Then if A is greater than B, then obviously the position of A should be at a position greater than B, no? Compared to B, A is on the right hand side. A is on the right hand side, but A is bigger because value increases when you go to the right hand side. These are basic things, right? These are basic things. If both A and B are equal, then both of them are on the same place. Both A and B are on the same position in the number line. Then if A is smaller than B, A is smaller than B, can B is bigger than A, no? Then B should be on the other side. These are small things, but still in calculations, based on this one only, we do the calculations. Right? If a number is bigger, it's in the right hand side. Rightmost side compared to the other one. Okay. So complete the notes. Those who have the tute can complete in the tute. Others quickly take the note as a short note. Online students, the board is clear, right? So absent, okay. Online students, the board is clear, right? I need individual responses quickly. Drop message in the chat box. Board and the audio both. Okay. Right. These are small things, so I'm not going to ask whether you understood this. Make it understand. Okay. Next. Interval notations. Now, this is very important. Most students forget about this when they write answers. Interval notations. Actually, these kind of set notation only. Interval notations. So let's say still A and B are two real numbers on the number line, right? I'm going to compare, I'm going to take set of intervals like this, where here on the number line, A and B are two fixed numbers. A and B are two fixed numbers, right? A can be smaller than B, or A can be greater than B. That situation is not the thing I'm going to discuss. Let's say X is an agent representing all the numbers in the number line. I'm writing like this. First case, X is a value greater than A, less than B, something like an interval, right? Greater here, X is greater than 2, less than 5. Can X is a value greater than 2, less than 5, which represents this region, right? Grade 9. So instead of taking specific numerical examples, I'm taking an algebraic example to write down the notation, just to give you an understanding about the notation. So this inequality says that X can take any value greater than 2, less than 5. X can take any value greater than 2, less than 5. That's the meaning. X can take any value greater than 2, less than 5. Now, how we are supposed to write this? As a interval notation. Remember, this thing is same as, okay, this thing is same as, here's here, X is an element, X is an element in this range. What range? Greater than A, less than B. No? There is no equal sign in any of the places, means we put the parentheses, right? Here, from the left to right only we write. Always remember, we write from left to right. Here on the left hand side, we don't have the equal sign. Therefore, on the side, we don't have the equal sign. We put a curved bracket, curly bracket, curved bracket, or as open parentheses, right? You know the names of the brackets, right? This is parenthesis, box bracket, curly brackets. Make it a special name. I can't remember the technical word. Okay. So this is open parenthesis. So we'll put this first letter A, or the first number, comma, the next margin is B, no? Next margin is B. A clear, no? Here we don't have an equal sign. Then again, close parenthesis. What if we have A, X is greater than or equals to A, less than B? Here, X is in this range, so we write it as X is an element. X is a number which belongs to, or X is an element within. This equal sign says that A is also a value that X can take. What's the difference between an inequality and an equation? Let's say X equals to 2 means X is 2 only. X can't take any other value, right? X is 2 only. X is not a variable. X is a fixed value in this case. If X equals to 2 means X is 2 only. Other than 2, X cannot take any other value. But if someone is saying X is greater than 2, it means X is not equals to 2. Other than 2, greater than 2, whatever the value that X can take, we can consider them. You can 2.00000000001 එකේ ඉඳලා ඔක්කොම X ගන්න පුළුවන්. But not 2. Because X is not equals to 2. If you are considering only the whole numbers, 3, 4, 5, 6 like that. If you are considering all the real numbers, 2.00 infinite many zeros and 1 is also greater than 2. No? එතනින්ද මුට ගන්න පුළුවන් values. But not 2. But not 2. That's the meaning of an inequality. It's an inequality, not an equality. Right? But if we have an equal sign here, it says that X can take 2 and values greater than 2. Not just one single value. X can take 2 and any value greater than 2. X can be 2 after that 2 point any other number and further. Till infinity, till positive infinity, it can take any value. If we are not setting a margin on the other side. That's the meaning. Alright? So, here X is greater than A. So, we have to say that X doesn't have a chance to get the value A. That's why we put the parenthesis. If you see that curved bracket, remember there is no equal sign. X cannot take both of these values, but X is a value in between these two values. For an example, before this one, we'll take an example. Let's say someone is saying X is greater than -1, less than +2. So we can write this as X is an element. No equal sign means parenthesis here, -1, comma, from left to right we have to write it 2. Here also we don't have the equal sign, again parenthesis. This curved bracket or parenthesis says that X is a value in between -1 and 2, like 0, 1, 0.1, -0.5, plus 0.5, 1.9, any value in between this X can take, but not -1 nor +2. X cannot take either -1 or +2. That's the idea, right? So this is the main idea. This is an example. Next, let's say X is greater than or equals to A but less than B. When there's an equal sign, it means that X can take that value and the value is greater than that. X can take that value and the value is greater than that. So X is an element. It can take that value and the value is greater than that. You see? X can take that value. If that value is also included, we put the box bracket. If that value is also included here, equal sign is there means X can take that margin value also. Then the box bracket A, comma, next margin is B, but unfortunately X cannot take this B. Can't take means methana curved bracket. So the place where you have the box bracket, we know that X is greater than or equals to A, less than B. Here, here there is no equal sign. So if you see this, you should be able to write this. If you see this, you should be able to identify the values of X also. Then again the intervals. Right. For an example, if someone is giving you like this, X is an element -2, 3. What does it mean? It means X is greater than or equals to -2 but less than 3. Box bracket එක තියෙන පැත්තේ equal sign එක from left to right only the values are increasing. So this is how the inequality will be written, right? Left to right means from smallest to biggest. So we have to have that convention, okay? Make order. If you change the order of this one, the idea is completely changing. It's wrong, right? Next, in the tude, I think when I'm typing, I missed to type X is an element කියන එක type කරලා නැහැ. So write it down, and I haven't written any of the examples. So all of you take this as a note also. Take this as a note. Tude එකේ විතරක් තිබ්බට මදි. ඔයාලා note එකක් විදිහට ගන්න. You take it as a note as well. Okay. Next, let's say there is no any margin on the other side. X is less than A. There is no any margin on the other side. එතකොට පුතා, the margin of, if there is no margin on this side means X is coming from negative infinity, no? But obviously remember, nobody can reach infinity. So X is an element from negative infinity, actually it's coming. We cannot put the box bracket because X is never going to reach infinity. Comma, A, here we don't have the equal sign, so it's going to be close curved brackets. Let's say X is less than or equals to A. Then X is an element. Still from the left hand side, we don't have any value, which means X is a value that less than or equals to a number. It goes till minus infinity. So minus infinity cannot be reached, so curve brackets minus infinity comma, it can reach until a equal sign is there, so a box bracket like this. Okay, so now වගේ තමයි අනිත් එකට understand කරගන්න තියෙන්නේ. I have given you the examples, so I will just write them down. හරි, so let's say x is a value greater than b. ඒ කියන්නේ greater than b, let's say b is some number greater than b means to the right hand side, no, to the right hand side. If you can remember, we discussed if this is like this, the biggest number is written on the right hand side, no, so x is going towards the right hand side, but from the right hand side there is no any limit provided. No limit means it can go until the positive infinity, no. From the b side equal sign is not there, so curve brackets b comma, it goes till positive infinity, infinity, again curve brackets, again curve brackets. Then where b is greater than less than or equals to x, now it's going to be x is an element box bracket b, because b is included, comma infinity, but never reaches infinity. Infinity එක අල්ලන්නවත් බෑ, so that's why curve bracket is there. What else? I think all the situations I discussed, no. තව එකක් කතා කරමු. x is greater than a, less than or equals to b. ඔහොම තිබ්බොත් we can say x is an element left to right, on the left hand side not equal sign, curve brackets a comma b box bracket. Hurry, box bracket. Now let's say x is greater than or equals to a, less than or equals to b. This one, x is an element equal sign on both sides, a comma b box bracket. Hurry. Now we can have these kind of situations. Name hitannako. This is a special situation which I haven't mentioned in the tube, so better to write it down. Let's say someone is saying x is a value, right? I'll take an example. X is a value greater than -1, less than 5, and put a comma. They say that and x is not equals to 0. ඒ කියන්නේ x is a value greater than -1, less than 5, but x cannot be 0. Then writing like this is not accurate. එහෙම නැත්නම් මෙහෙම ලියන එක කැතයි. Which means x is greater than -1. Let's say x can take only the whole numbers for an example. It can take any value according to this inequality in between this -1 and +5. Let's say x can take only the whole numbers for an example. If it is if it can take only the whole numbers, greater than -1 means 0, 1, 2, 3, anything. But they say that x is not equals to 0. Then writing the inequality like this is not correct. Make a kathay, make a lasana naha. So what we do is, if it is like this, we have two methods. Method 1, we divide the inequality in two ways. Number 1, x is greater than -1, less than 0. Less than 0 දාපු ගමන් 0 is not included. Okay, 0 is not included. ඊට පස්සේ union in set notations. Union x is greater than 0, less than 5. If you write like this, people know that union means consider all of them within these two sets. Consider all of them within these two sets. Ignore 0. 0 ගන්න එපා. 0 ගන්න එපා because equal sign is not there for 0. Right? Obviously -1 + 5 is not included. This is one way. Or else, from the method we studied, we can write like this. කොහොමද? X is an element In what set? -1, 5. But not 0. No? So we put a slash inside curly brackets. We put the 0. In exams, in final exams, the come here, come here, both of you. Then this side, if you sit on that side, I think this side also will be visible. Sit and see. Huh? You can't see because of the laptop. Isn't it? Right. So in final exams or in my papers, if you see, you should understand I'm giving the domain of X. I'm giving the domain of X where what 0 is not included, or any other number also we can put. This is a special idea. Okay. This is a very important idea. Within a given range, not all the values are taken. If particular value or values are excluded, we can write like this. Okay. For an example, if I give you another example here, if I give another example, let's say someone is saying X is an element from +2 to +10, but 10 is not included. Okay, metana box bracket එක. When you are writing the brackets, please carefully write it nicely. Okay, and they say that 1 කොහොමත් නැහැනේ. 3, 5 are not included. What does it mean? 2 to 10, all the values are there, or 2 to 10, we can take any value. Let's say they are saying X is an element in this, X is an integer. The maths over read කරන්න පුළුවන් වෙන්න ඕන. When you see these kind of notations, if you take a mathematics reference book, not O-level maths reference books, A-level maths reference books, advanced mathematics reference books, this is how they write down the notations. Right? A simple thing, if they want us to explain, they will write in notations. You should be able to read and understand. So here they have given two conditions. What is it? Number one, first of we have to usually write the main domain first. Let's say someone is saying X is an integer, comma means and X is an element in this range. X is an integer and in this. If you take only this range, it says greater than 2, less than 10, any value, 2.1, 2.2, 2.00009, everything. All the values are included if you are taking like this. But if they put another condition that X is in integers, then it means within this range, you consider only the integers. Decimal values, only the integers you are considering. So according to this one, if I write the elements of this set, this is a set. If I'm writing the elements of this set, okay, if I'm writing the elements of this set, what are the elements? 2, we have the square bracket, then 2 is also included. 3 and 5 are not included. Then 3 and a half, 4. 5 is not included. 6, 7, 8, 9, 10 is not included. Why is that? Curve bracket in there. So these are the elements. But from this, you don't have any calculations to do in A levels, right? Make a university level okay, if anyone is doing engineering or maths or obviously then how about software engineers? Software engineers make an software develop if you are developing a library management system, right? Nowadays, if you program a library management system, I'm a software engineer. If you take ChatGPT give me the code to develop a library management system in R or in Python or in any R Python or Java or whatever the language programming language you want, software engineering. But that's not software engineering, software development, coding. Software engineering kernel minister. Okay, right. So if there some from this point onwards there is no note in the tute, take this example also, online students. Drop a message in the chat box. Clear with that. I need individual responses. I need individual responses. Drop a message in the chat box quickly. Clear, understood. Tagala. Latecomers, I will send you the TOT in the chat box. For the moment, take this note. Right. Then යමු ඊළඟ වැඩට. Next is what we call as, some people call that as trichotomy law, some people call that as trichotomy law. කැමති විදිහකට කියව ගන්න. We are Sri Lankans, we don't read පිටිපස්සේ. You keep it. I will give you the vector tutor in the other lab. When you are leaving, remind me, I'll give you the coordinates geometry tutor also. Vector tutor I will give you in the class. Right. එහෙනම් ලියන්න ඊළඟ එක trichotomy law. එහෙම නැත්නම් trichotomy law. Chotomy නෙවෙයි ඈ. So that's a very basic one. Right. Number one, if A and B are two real numbers, A is less than B or A is greater than B or A equals to B, one of these is true. Right. The trichotomy law, the law is this. You see, let's say A and B are two real numbers from the set of real numbers, right? They say that either A is greater than B or A is less than B or A is equals to B. What does it mean? If you consider two numbers, both numbers should be equal, or one number should be greater than the other one or less than the other one. If I'm selecting a particular number, that number is equals to the other number or greater than the other number or less than the other number. They say that it happens one of these instances only. Obvious, no? One number cannot be greater than or equals to the same number. 5 cannot be greater than or equals to 3. 5 can be greater than 3 only, that instant only. Then so when we are writing inequalities, we are writing x is greater than or equals to 3. Then this law is not valid here. No? The මෙතන කියන්නේ number එකක් නෙවෙයි. This is a variable. This one represents all the numbers that is greater than or equals to 3. 3, 4, 5, 6 ඔක්කොම represent කරන එක. If I'm selecting if I'm selecting x equals to 5 instant, then 5 is not greater than or equals to 3. 5 is greater than 3 only. When we assign a value here, මෙතන A and B are real numbers. We consider specific two numbers, not an agent. Okay, so when we consider particular instant, at an instant only one thing can happen, only one of these conditions can happen, not all three of them. That's what the law says, right? So the everyone write this down. Okay, online students liyanna, physical class students already given in the date, but kamak naha liyannako. Right, if A and B are real numbers, write like this. If A comma B are elements of real numbers, if A comma B are elements of set of real numbers, you can write like this, no need to write the full sentence. If A and B are elements of set of real numbers, put a comma, A is greater than B or A is less than B or A is equals to B. A is greater than B or A is less than B or A is equals to B. A is equals to B. Full stop. and write exactly one of these is true. 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 Right. Now, we're going to discuss some important things. Write down the first star point. Write down the first star point. Write down the first star point. The sum and the product of two positive integers or integers two positive numbers the sum and the product of, put a star mark below important these are some important discussions. Important, put a star mark and write the sum and the product of two positive numbers, not just integers, any positive number. The sum and the product of two positive numbers, the sum and the product of two positive numbers, the sum and the product of two positive numbers is a positive number, is a positive number. We discussed this condition in one of the other previous lessons. What is it? Lesson in one of the calculations. Proving that two roots are positive quadratics. We discussed the same idea in quadratics also. Right. If the sum, if the sum and the product of two positive numbers are positive, or okay, the sum and the product of two positive numbers is also positive number. Now here see, I'm considering two numbers A and B. I have a number A and I have another number B, and I'm taking these numbers are elements of set of real numbers, not all the real numbers. I'm considering only the positive real numbers. So this is how we write. I'm considering positive real numbers for A and B. If so, if A and B are positive real numbers, if two numbers are positive, they say that A plus B, sum of the numbers is also positive, and not O. Okay, O means this, O this, and means both of them are true. A plus B, or the sum of the numbers is also positive, greater than 0, and the product of the numbers is also positive. Product of the numbers is also positive. So that thing that you written in words, this is how we denote it mathematically. A method notation. So write it down. Quickly write it down. These theories are important to understand the calculations. Calculations at the I have given 8 theorems. All 8 theorems are not needed. Right? ඊට පස්සේ calculations ගියාට පස්සේ පුතා theory නෑ. ඊට පස්සේ එක දිගට ගණන් හදන්න තියෙන්නේ. Right? Tayyib Imtaz Akif. So still from the other Monday batch class එක අද තියෙනවානේ. Yesterday's class we scheduled it for today. How's the class එකට ආවේ නැත්නම් set එක මම ගහලා පන්නනවා පන්ති. Right. Write the next. Write the next star point. Write the next star point. Write the next star point. The sum of two negative numbers is negative. The sum of two negative numbers is negative. The sum of two negative numbers is negative. And the product of two negative numbers is positive. Second star point. The sum of two negative numbers is negative. The product of two negative numbers is positive. The sum of two negative numbers is negative. The product of two positive numbers is positive. Again, let's say if two numbers are there which are negative real numbers. Those are negative real numbers. If so, the sum of these two negative real numbers is also a negative number, which means -2, -3, -2 plus -3 means -5. It's a negative number. It's less than 0. And The product of the negative numbers is obviously positive, not negative. If I multiply two minus values, it's positive. That's a theorem. Theorem, actually, it's an axiom. Right. Write this down quickly in notations. Quickly in notations. These notations I'm giving because in papers you can't expect them to explain everything in words. They will be giving you in notations. Then you have to read the domain and understand them. Right. So 27 A level batch, ඔයාලගේ class structure එක පොඩ්ඩක් change වෙනවා. Usually I start the class straight away with the theory. So from the beginning I was planning to give you the papers. Now the papers taken and ready. So class has been divided into 3 sessions. The first session is for the paper writing, a half an hour paper එකක් දෙනවා. So if late comers can't do it, exactly the class starts at 3:30 and 3:30 to 4 the paper will happen, and then 4 onwards discussion එක, ඊට පස්සේ applied discussion එක, after that the paper discussion එකකින් පස්සේ තමයි class ඉවර වෙන්නේ. So if you ask me at what time class finishes, if I usually if I'm giving you the time schedules, Saturday online batch class starts at 7:30 on Saturdays, right? 7:30 p.m. to 11:30 12 වෙනකන් යාළුවගේ class එක යනවා. Since we are taking applied mathematics also, පුතා we usually 26 batch එක කරන classes දෙකක් කරනවා, pure maths, applied maths. But for 27 A level batch I can't do it because students are unavailable. Everyone is not available in one single day. It's like scattered time schedule දෙන්නේ. So can't put 2 days for 2 theory classes. So one single theory class, applied and pure will be happening. Like trigonometry, currently we are doing trigonometry last part, no? Trigonometry last part, and then after that applied mathematics vectors we are doing. Trigonometry වුණාට පස්සේ full day applied අරගෙන we are finishing the vectors lesson. And then after that the next applied lesson will be starting. ඒක ඉවර වෙන්න ලඟ වෙද්දී I'll be starting the next pure maths, pure part, right? When the applied lesson is like 90% completed from system of coplanar forces, I'll be starting the pure maths calculus as well, right? And එහෙම තමයි යන්නේ. So otherwise in a mix, 2 big lessons we can't do. 2 big lessons we can't do. So however, a class will be not just 5 hours, sometimes 6 hours, 7 hours වගේ යන්න chance, 6 hours වගේ යන්න chance එකක් තියෙනවා. If it is a class that goes on weekends, physical, Sunday physical batch, class starts at 2, finishes at 7:30. Okay, I can't take more than that because transportation issues are there for students. So 7:30 is the maximum that I can take the class. Monday physical batch, the class starts at 3:30, finishes at 8. But the thing is, එතන උන්ට තියෙන්නේ 4.5 hours only, right? So then sometimes I might be taking the class bit early, like Sinhala medium classes. Sinhala medium classes starts at 2:45. No? So කෙලින්ම මම 2:45 පටන් ගන්නවා. No sir, we have to go home and come. That's not my problem. Hare, you can't go home and directly come to the class. Because when we were doing A levels, from Maradana to Nugegod, we have to come. So class, our school finishes at 1:50. No, I studied in Zahira College, so Zahira College finishes at 1:50. Right, 1:50 එවරුණාම 2:05 train එක. So quickly we are rushing to the station. 2:05 train එක ගත්තා, කෙලින්ම ඉන්නේ නුගේගොඩ. When we are coming to නුගේගොඩ somewhere around 2:30 2:35, I can remember physics paper class started at 2:30 those days. So train එකේ බැස්ස ගමන් ගියා class එකට, right? Theory classes started at 2:45, right? So එහෙම class ගිහිල්ලා class 7:30 6:30 7 sometimes 7:30 තමයි classes ඉවර වෙන්නේ. ඉවරලා තමයි ගෙදර යන්නේ. If in the beginning also I told you, if you are not ready to do such sacrifice for your education in A levels, don't forget, completely forget about your A pass, right? Because this is maths, no? If you take the commerce stream classes, feel you very chill na bango. Class starts at 4 p.m. weekdays classes, or 5 p.m. ගෙදර ගිහිල්ලා lunch එකත් අරගෙන නිදාගෙන නැගිටලා fresh පිට යන්න පුළුවන් class. That's their subject, right? Even the accounting class only 2 hours. Accounting revision එක maximum යන්නේ 4 hours, right? My 2026 A level revision is happening from morning 7:30 to evening 4 with a half an hour break or half an hour 45 minutes break only. That's why the maths and the biology is for some certain selected number of people. That selected number of people are special people. Unto ඕන තරම් වෙලාවක් they can hold the complexity. උන්ට දරාගෙන ඉන්න පුළුවන්. Right? You have to recheck whether you are capable of doing that. Hard smart work කියලා විතරක් කරන එකේ තේරුමක් නැහැ. When it comes to mathematics, hard work is required. Right? Hard work is really needed. You have to work really hard to get the A pass. නිකන් හම්බෙන A pass එකක් නෙමෙයි. Within 3 hours entire syllabus, 2 years of syllabus, and not just one lesson. Patta lesson ගොඩක් තියෙන්නේ. Applied math paper in one single essay question we had 2 different lessons to answer. Right? Lessons දෙකකින් questions ඉන්නේ අමාරුයි. Yeah? So පුතා my classes class hours ගාන වැඩි, number of work is higher. දරාගෙන යන්න ඕන. If you trust me and work properly, that's the main condition, and work regularly, ඒකක් ගන්න එක අමාරු නෑ. If you are expecting me to finish the class in 3 hours, 4 hours now, then in 3 hours, 4 hours class කරලා කරන්න බෑ. I can do it by increasing the discussion speed. හිමින් කරන්න හම්බෙන්නේ නෑ. This lesson maximum 2 hours, 3 hours theory. But I am doing it very slowly because I don't want to rush the process, because I want to make sure that like physical class students, online class students also understand the things. Then හේතුව මෙතන in the crowd online එකේ crowd එක වැඩිනේ. Right? ඒකෙන් දැන් මෙතන ගොඩක් උන් absent. Right? Some of the physical class students not joined online and physical both. ඒ දැන් ළමයි 6ක් 17ක්ද absent, physical and online both දෙකේම නැහැ. Somewhere around 5 to 6 students of online students are absent today. Right? So somewhere around තාමත් nearly 10 to 11 students are absent. Right? So I think that's their problem. Right? They are thinking going through the recordings is okay. Samaharunta පන්ති ඉන්න බෑ because they are prefects in school. අනේ මන් දන්න පුතා, again I'm telling, if you can't sacrifice the other things for your A level maths, you can't do this. O level එකේ කරා වගේ doing the extracurricular activities and trying to do this, can't do. School projects I have school projects, I can't participate in classes. If you have another physics class or a chemistry class clashing with this seminar, no problem. That's a very valid reason. Right? You can prioritize whatever the complicated subject for you. Physics or the chemistry sir can't say not to go to the math seminar, or maths I cannot say don't go to that one. You have to choose what is suitable for you, because all the subjects are equally important. Alright? But if it is ICT, මම නම් කියන maths වලට වරෙන් කියලා. Alright? If it is an ICT seminar falling on maths seminar day, I'll be asking you all to come to maths. ICT කෙතනද වැඩ කරන්නත් පුළුවන් නේ බා. Right? ඒ වුණාට you will have to understand this and work. Right? Next, sum of a positive number and a negative number can be positive or negative, but the product is always negative. Now here see, write the third point. Sum of positive number and a negative number. Write this. Sum of a positive number and a negative number. Sum of a positive number and a negative number. SUM summa, not SOME sum. SUM sum. Sum of a positive number and a negative number. Sum of a positive number and a negative number can be positive or negative. Can be positive or negative, but the product of a positive number and a negative number, but the product of a positive number and a negative number is always negative. The sum of positive number and a negative number can be positive or negative, but the product of a positive number and a negative number is always negative. So let's say A is a positive number, but B is a negative number. A is a positive number, B is a negative number. Here's a yeah. If I add A and B based on the magnitude, this can be either positive or negative. For an example, I'm taking +2 and -5. When I take the sum of them, answer is -3. It's negative. But I'm taking +5 and -1. If I'm adding them, +4. It's a positive. So depending on this one's magnitude, minus sunata, okay, size එක. Based on that, it can be either positive or negative. And obviously, the product of these two is negative. There is no debate in this. Product, it can be any positive number, it can be any negative number. If you multiply them, it's going to be obviously negative. That's the main idea. So write this down quickly. Write this down. Right. ඊළඟට තියෙනවා some theorems, there is no any order for these theorems, so there is no any specific count for these theorems. So I have given space for 8, but actually 8 theorems කියලා නෑ. I'll be combining some theorems together and giving. So somewhere when you are writing, you will be writing somewhere around 5 to 6 theorems only. Okay, right. Write theorem number 1. There is no any specific order to remember these theorems, even though we give as numbers. Right. Write theorem number 1. Theorem number 1. Write in words. Write in words. Write in words. If A, B, C are real numbers, how do we write like that? How do you write it? If A, B, are elements of set of real numbers. This is how we write. If A, B, C are elements of set of real numbers, put a comma and write. Put a comma and write. And put a comma and A is greater than B or A is less than B. If A, B, C are elements of set of real numbers and A is greater than B or A is less than B. A is greater than B or A is less than B. ලියන්න මෙහෙම below that. Here see ya. Stop working and listen. A is greater than B or A is less than B. කොහොම no problem. Okay. We can add the same value to both sides of the inequality. Okay, we can add the same value to both sides of inequality. It doesn't change the sense. Sense එක මාරු වෙන්නේ නැහැ. We call this the sense. Okay, we can add the same value. Can add the same value to both sides. Sense won't change. Sense will not change. Sense will not change. Inequality sense එක change වෙන්නේ නැහැ. We can the same as when it comes to equations, we can add the same value to both sides. Same as that. This is theory 2 actually, but we can write it in the same theory itself. Okay, we can add the same value to both sides. That is one. The other thing is can subtract the same value from both sides. Can subtract the same value from both sides. It can be A is less than B. You will get A minus C. Then A minus C is less than B minus C. Can subtract the same value from both sides. Still the sense won't change. Inequality sign එක change වෙන්නේ. Sense won't change. Sense won't change. You have to maintain the proper order. Okay, A in the පැත්තේ එහෙම maintain කරොත් තමයි ඒක පේන්නේ. A is greater than, if A is greater than B, I can subtract C from both sides. If A is less than B, then also I can subtract the same value from both sides. Okay, subtract the same value from both sides. This is theorem 1 and 2 together. Okay, you can just write them under theorem 1 itself, no problem. Next, I named it as theorem 1 and 2. Let's take the theorem 3 and 4. Okay, so you can write this with me now. You have the idea, no? So let name if A, B, C are real numbers. If A, B, C are real numbers, okay. So now we are discussing a general situation. If there is an equal sign, also the same thing we can do. Equal sign but no problem, right? Real numbers, and A is greater than B or A is less than B. Any situation, right? Case 1. Case 1. Okay. Case 1 එකේ here see ya. Now I'm discussing multiple theorems to a case and C is positive. Right. So theorem 3 and 4, C is positive. Not case 1, case 2. You see? A is greater than B. එහෙමනම් here මෙතනත් පුතා මෙහෙම ලියන්න. A is greater than B implies this arrow head එක දාලා. This is A is less than B. Then I can add the same value to both sides. It doesn't change the sense. මෙතන A is greater than B. I can subtract the same value from both sides. A less than B වුණත් I can subtract the same value from both sides. That's not actually true. අපිට දෙපැත්තෙම එක for both sides we can add the same value, from both sides we can subtract the same value. Right? Now, A is greater than B if C is positive. Here, if C is positive, here AC is greater than BC. I can multiply both sides with the same value. If A is less than B, still the same thing. AC is less than BC. We can multiply with here, multiply both sides with same positive value. Sense will not change. Sense කියලා කියන්නේ this inequality sign. Okay, inequality sign won't change. It will be in the same order. A left tongue, A විදිහටම තියාගෙන ලියන්න. Same as that, A is greater than B. I'm dividing with C. Okay, I'm dividing with C. Sense won't change. A is less than B. I can divide with C. Sense won't change. You can write the note. I'm not going to write it. You can write it. Can divide both sides here. Can make a can multiply. Can divide both sides with the same positive value. It's important. Positive value. Sense will not change. Sense will not change. Sense will not change. Can divide both sides with the same positive value. Sense will not change. 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 Then hanging next. Theorem 5 and 6. Let's say if A, B, and C are real numbers and C is negative, it can be A is greater than B or A is less than B. කැමති විදිහක් වෙන්න පුළුවන්. Let's take this condition, A is greater than B. Still in the inequality, listen now this is important. Still in the inequality, I can multiply both sides with the negative number. Can multiply. But what happens? Sense will change other way around. A is greater than B becomes AC is less than BC. Sense will change. It can be A is less than B. If I'm multiplying with a negative number, sense will change. Can multiply both sides with a negative number, sense will change. Sense will change. Sense will change. When you add the positive number to both sides, when you subtract a positive number or a negative number, if you add a number to both sides, subtract a number from both sides, doesn't matter, sense will not change. Multiply both sides with a positive number, divide both sides with a positive number, sense will not change. But if you multiply with a negative number or divide with a negative number, you see, A is greater than B, A is divided by C, B is divided by C. Greater than becomes other way around. A is less than B. A divided by C becomes greater than B divided by C. Sense will change. So can divide both sides with the same with the same negative number. Okay, with same negative number. Okay, you can write the note. Can divide both sides with same negative number. Sense will change. Sense will change. Sense will change. Take the notes carefully. Sense will change. There's another instance we have to discuss where the sense will change. ඒකත් එක්ක theorem ටිකක් දාන්න. Right. Right. Next. Theorem 7. Right. So let's say A, B, C, and D are elements of set of real numbers. A, B, C, D are a set of real numbers, and it's given that A over B is greater than C over D. Okay. Or A over B is less than C over D. Now, in calculation, let's say A over B is greater than C over D, if I am taking the reciprocal of both sides, if I take the reciprocal of both sides, it gives me B over A, D over C. And when we take the reciprocal, what happens? Inequality changes. Inequality ka change, sense changes. So it can be A over B is less than C over D. Still, when we take the reciprocal, it can be B over A and D over C. Inequality ka anit patta gahana. Inequality changes. So when we consider the reciprocal, okay, inequality changes. When we consider the reciprocal of both sides, inequality changes. When consider reciprocal, you have to consider from both sides. Huh? Inequality changes. Quickly write it down. Quickly write it down. Quickly write it down. තාම inequalities හරියට පටන් ගත්තේ නැහැ. Still we are doing the theory. Theory is done now. Right. Theory 8 එකක් ඕනේ. Right. In third page, there is a question. Online students, write down the question. Write down the question. ලියන්න මේ ප්‍රශ්නේ before we start the actual calculations in inequalities. Write down this question. Then තමා ගණන් පටන් ගන්න. Write down this question. If A and B are two positive real numbers here, if A comma B are two positive real numbers, write like this. If A and B are two positive real numbers, write the question. If A and B are two positive real numbers, such that A is not equals to B. A is not equals to B. A is not equals to B. Prove that A cube plus B cube is greater than A square B plus AB square. Prove that A cube plus B cube is greater than A square B plus AB square. Right? I'll give you a hint. Take the left hand side of the inequality as an expression and then try to do the simplifications. Sum of two cubes expansion is required, which we studied in the first days of combined maths. Karannako balan. Give it a try. Give it a try. Continue. After this question, solving inequalities part we'll discuss. Ek podi part එකක් තියෙන. After that, calculations only. Then modulus functions. After the break, we'll discuss about modulus functions. After that, past papers discussion ඒකත් එක්ක මේක ඉවරයි. Right. So they say that A and B are positive real numbers such that A is not equals to B. Prove that A cube plus B cube is greater than A square B plus AB complete square. So first of all, we'll take this expression as capital E because I need to develop this inequality. Before that, first of all, consider this capital E expression. Let's try to give a simplification for that, right? This is A cube plus B cube, no? So we know that sum of two cubes, how do we expand it? How do we factorize it? Forget about the cube, write the expression A plus B. Open a bracket. First term square, product here, plus num metana minus, product of the two terms, AB, second term square, B square. That's the expansion. We studied this one, polynomials wala magadi kara. Right? At the beginning of the classes. What did you do? Forget about the cube, write the expression, first term square minus product of the two terms plus second term square. Now I need to get this expression somehow from this one. Mugen hadaganna ona. Okay, I need to get this expression somehow from this. Right. For the moment, what we can see, Buddha, this one is A square plus B square means, you see, දැනට පේන්නේ මොකක්ද? A plus B, I'll put a box bracket because I have to use two brackets here. A square plus B square can be written as A plus B complete square minus 2AB. Right? Again, minus AB. These simplifications we have already discussed in our previous classes. Sorry. So we totally get E expression A plus B cube times, sorry, cube minus A plus B times 3AB. එහෙම නැත්නම් මම මෙහෙම ලියන්න minus 3AB no. So minus into plus equals to minus 3AB times A plus B. Now check this one and try to get an idea how to simplify this and consider this condition also. Muvat hitala වැඩ කරන්න. Think about that one as well. Think this, think about this and do this. Right. Now I have did the simplification up to some level. You think. Now based on the conditions, you think. Based on the given conditions, you think. I'll give you a couple of minutes and then I'll discuss. Done. Okay, no? Online students, fine. Okay, now listen. In this inequality, now we have come to this point. Now here see, we can consider all these expressions by taking to the left hand side, by making the right hand side 0. You see, not taking to the left hand side. You can remember, right? If A is greater than B, right? Which means A minus B is greater than 0, no? If A cube plus B cube is greater than A square B plus AB square, then this one minus this one is should be greater than 0. May idea match with this. So I think if we go that way, the simplification is more similar. If I'm going like this, then I will have to put this one again. Again bracket remove. So it's time consuming and recurring work. So what I will do is like this. You can do continue with this simplification if you want, but I will amend the simplification like this. Now here see, A cube plus B cube is greater than A square B plus AB square. What I'm going to do is I'm taking this expression to the other side, not taking to the other side. We are not taking B to this side. That's not the concept. If this is happens, it can happen only if this happens. That's the condition. Because of that only we are writing like this. So don't think that B is coming here, so we can write like that. Right? There is no theory like that. So A cube plus B cube minus A square B plus AB squared greater than 0. If something is bigger than the other one, the difference of them is bigger than the 0, is greater than 0. Difference means from the big one minus the small one bigger than 0. Now remove the brackets and write A cube. I write A square B with this, A square B plus B cube minus into plus equals to minus AB square. I'll take like this. Why I'm writing like that? Because I can see I can take common factors. No? The methaning gattot. What are the common factors we can take? From here I can take A square as a common factor outside. No? So I get A minus B. From these two, I'll take B square as a common factor outside. So I will get again A minus B is greater than 0. Now here see, yeah. Now here see. A square times A minus B, B square times A minus B. I'll take A minus B as a common factor outside. So we get A square minus B square. This is in the form of a difference of two squares. Again, we can factorize. So we get A minus B. This one, when we factorize it, we get A minus B times A plus B. Right, like this. What is this? This is A minus B complete square times A plus B is greater than 0. Now listen. It is given that A is not equals to B. It is given that, 1 minute. Guys, give me a minute. Our class එකක් තියෙන එක start කරලා. So in this, here a is not equals to b, so a minus b cannot be 0, but whatever the value that comes inside the bracket, when you square it's going to be plus. A plus b is obviously plus because sum of two positive numbers is positive. So again, obviously this is positive. Condition satisfied, right? So this is true. Mega ආවේ කොහෙන්ද? මෙන්න මෙතනින්. So I will come to that part quickly. Write this down, will you? I'll come. Right. Sorry about it. Now listen. දැන් බලන්න වැඩේ. A is not equals to b, therefore obviously a minus b square is positive. And a plus b is obvious here. A and b are both positive integers, therefore a plus b is obviously positive. Therefore, this expression, if I take it as 1 or star is true. Make a hurry simplification. This is valid. Now here see. Listen now. What did we consider? Our idea was if a cube plus b cube, if this is greater than a square b plus ab square, this can happen only if a cube plus b cube minus a square b plus ab square is positive. But from where did we get that idea? If there are two numbers in real numbers set, and if one is greater than the other one, a minus b is greater than 0. The same thing, instead of just two numbers, we got an expression. Still a and b are numbers. When you simplify them, here you get a number, here you get a number. A number greater than another number means bigger one minus the smallest one should be greater than this. They wanted us to prove this. They wanted us to prove this is true. So what did we do? If we want to exist this one, if we want to prove this one, then we need to prove that this one is true. Make a true num if this must be true. So we took this one and did the simplification. We found that from this simplification it's true. Okay. Since a cube plus b cube minus a square b plus ab square, it was equals to the simplified expression a minus b squared a plus b, which is greater than 0. We proved it. Therefore, a cube plus b cube is greater than a squared b plus ab squared. Make a true hinda, this is true. They wanted us to prove that this is true. Is true. Even is true. Even correct. Okay, so that's a nice application. Now write the topic: solving inequalities. Solving inequalities. Now write the subtopic: solving inequalities. Solving inequalities. Solving inequalities. දැන් ආපු නැති කට්ටියට හින අපරාධයක් ඉතින්. When they had the chance to cover up 25 marks of the paper, I mean pure paper, 1000 වලින් 25 marks cover කරගන්න තිබ්බ chance එකක් නැති කරගත්තා. If you are expecting me to upload this recording also to the YouTube, please do the one. ඔක්කොම upload කරන්න YouTube. I'm not going to provide the recording of this, unless if it is a valid reason they can get the recordings. Otherwise, absent students කරන්න දෙයක් නැහැ. They can take the note from their friends. Right, I'll erase the board. I'll erase the board. Right, solving inequalities. මෙතන if කියලා දාන්න එපා. If you are writing if, then instead of the if and only if sign, then කියලා දාගන්න. Don't put the if here, and here write it as proved. Write it as proved. Right. Now write solving inequalities. Solving inequalities. Let's try the first example. Let's do the first example, example number 1. Solve 3x minus 2 greater than 0. Remember, solving an inequality means we find the range of values, not a specific value, a range of values for the unknown term, or as the algebraic term. Now here, listen now. The original application is this. When it comes to equation, also the same thing, but we directly do what? We take that minus 2 is going to the other side. The application is that if you want to solve, if I want to remove a minus, I put a plus on both sides. This is how we do it properly if we are doing it. Just to save the simplification steps, directly we can write it as 3x equals 3x is greater than plus 2 directly we can write. But this is the application, remember, okay? Not 2 is going to the other side. Okay? You can write like this directly. But remember, this came because we added 2 to the both sides. Alright? So we get 3x is greater than 2. I want to subject x. Right? So I added the same value to both sides, sense won't change. I'm dividing both sides with plus 3. Still the sense won't change. Sense එක change වෙන්නේ. So we get x is greater than 2 over 3. X is greater than 2 over 3. You can write the answer x is greater than 2 over 3 like this. X is greater than 2 over 3. No problem. How do we write this one in an alternate way? x is greater than 2 over 3 means x is an element greater than 2 over 3. 2 over 3 comma greater than, that means to the right hand side goes to positive infinity. We can write like this. This is another way of writing the answer. I'll write it below this one. X is an element greater than 2 over 3 means 2 over 3 until positive infinity. This is another way of writing the same answer. This is another way of writing the same answer. Harine? Right. So take it as method 1. Method 1. Method 2 is the graphical method. Method 2 using graphs. Using graphs. Yes, yeah. If you are using graphs, what we do is, yes, yeah, 3x minus 2 is greater than 0. Let's recall the trigonometry solving equations by graph part. What did we discuss? Taking the left hand side as one expression and the right hand side as another. Here, taking the left hand side as one function, right hand side as another function, and plot them in the same Cartesian plane, same coordinates plane. So if you want, you can take 3x minus 2 greater than 0 or 3x is greater than plus 2 situation make aragena karannat puluwan. That is another way. I think it's easy to go with this. I will take this side as fx, one function, this side as another function, gx. So fx is equals to 3x minus 2. It's a straight line. Gx equals to 0. It's another straight line, which is the x-axis. We studied those things. Now take some coordinates to plot this one. When x equals to 0, you get f0, which is equals to minus 2. One coordinate, 0 comma minus 2. When x equals to 1, to draw a straight line, having 2 coordinates is more than enough, but I'll take 3 coordinates. When x equals to 1, we get f1 is equals to 3 minus 2 is equals to 1. Okay. And then again, I will take when x equals to 2 over 3, below 1, f2 over 3 is equals to 0. I selected this value such way that මට මෙතනට 0 එන විදිහට එකක් ගත්තේ. Because it's easy for me to identify the intersection point. එහෙම නැත්නම් no need to get that value. When x equals to minus 1, we get f minus 1 is equals to minus 5. Or as you can take plus 1 and do it. හරි. කැමති විදිහකට කරගන්න. So now I'm going to plot this one on a Cartesian plane. You can take measure using your ruler and do it. Don't take it with eye balancer. Eye balancer you won't get the answer. X-axis, y-axis, origin. Right? When x equals to 0, y equals to minus 2. Plus minus 1, minus 2. When x equals to 0, y equals to minus 2. One coordinate. When x equals to 1, y is also equals to 1. Same gap, same gap. So here we have another coordinate. Right? I'll take this as plus 2 Buddha. It's easy for me to do the simplification. I mean, draw the graph. When x equals to 2, 3 times 2 is 6. 6 minus 2 is equals to 4. Y is equals to 4. 2, 3, 4. So we get a straight line segment like this. This is our y equals to fx equals to 3x minus 2 graph. Right? And this is our y equals to gx equals to 0 axis. Both graphs plotted on the same Cartesian plane. intersection point, y coordinate is going to be the solution. But if this is an inequality, if this is an equation, මෙතන තියෙන value එක 2/3. If you plot it properly, okay, if you plot it properly, you will get the value 2/3. ඔයාලා හරියට measurement එකක් අරන් ඇන්දොත්. Okay, since this is just to get an idea, just draw like this. But the thing is, Puta, we need to find what? Where the graph is greater than, graph is bigger than 0, graph is positive. What is this? Fx is positive. Basically, we need to get, what's the idea? We need to check 3x minus 2 is greater than 0, which is fx is positive, no? Where this graph is positive, graph has two sections, no? Below this here, when the x values are going below 2/3, graph goes to the negative side. When the x values are going above 2/3, graph goes to the positive side. The solution is going to be x is, for x greater than 2/3 region, function is positive. Function is positive. My idea is very important. Huh? This is a 2/3. Below 2/3, whatever the x takes value, corresponding y value is a minus value. We need the y values to be positive. And above 2/3, all the y values are positive. At 2/3, y value is 0. Since the equal sign is not there, equal sign won't come here. If the equal sign is there, function can be 0. Function is 0 when 2/3. Since the equal sign is not there, to satisfy this inequality, 2/3 won't be included. That's the margin. Right? So above 2/3, if you take any x value, we can see the corresponding y coordinate. Corresponding y coordinate is positive. So above 2/3 for any x value, the graph is positive. So finding the range of values of x using the graph means what? Wherever the graph here, this condition satisfy what are the x values? You did the same idea using parabolic functions or as quadratic functions in O levels. O level graphs may prashna hano. Right? Find the range of values of x, satisfy that y is greater than 0, fx is greater than 0. Those questions are there in O levels. Same thing here. The same idea is added in modulus functions also. But if in exams, if they ask you to solve the algebraic inequalities, no need to go with the graphical method. You can directly go with this method. If they ask you to plot the graph, then you will have to plot the graph. Then you will have to plot the graph. Right. Finish the question quickly. Finish the question quickly. Okay. Let's do the example number 2. In example number 2, graphical method is there, but I'm not going to do that part because it's a quadratic function. Quadratic function වලට graph වන්දින්න ගියාම වෙලා යනවා. Right. Example number 2. Now stop working and listen. Example number 1 was a linear function. Example number 2 is a quadratic inequality. So we get x squared plus x minus 6 is greater than or equals to 0. Listen very carefully. Good practices. when we solve an inequality, number one thing, double check, do we have one of the sides 0? If not, in a proper way, logical way, make one of the sides 0. Why are a logical way? You will understand it when we discuss the next one. Hurry. What we do is, first thing, check is one of the sides in the inequality is 0 or not. Not always you are going to get 0. Obviously, you will get values on both sides. So you have to make one of the sides 0 by considering a proper simplification. Now this is already 0 in the prashna. Next important thing is, I'm not going to give this as a note, make a podi deval. So remember that these are small things but important things. Next thing is, factorize the side which has the expression fully. Usually we try to keep the expressions on the left hand side. Factorize the left hand side fully as much as you can. Puluwan tharmak factorize karanna. So here I have x squared plus x minus 6. We can factorize this, just a normal quadratic expression. No? So factorize this one, we get minus 16 plus 3 minus 2. So if you factorize this, you get x plus 3 times x minus 2. Factorization kila then don't know. Right? Remove the brackets and see x squared minus 2x plus 3x plus x plus 3 times minus 2 minus 6. Make it now. Right? Fully factorize it. Number one, what we have to do? Number one, if you want, you can write down, make one side 0. Number two, factorize other side fully. Number three, identify values that makes the function 0 or undefined. 0 or undefined. Make one side 0, factorize the other side fully, identify values for x, for unknown term. In the usually you get x, but I'll write generally unknown term kila. Identify values for unknown terms such that this function is 0 or undefined. Even though you have an equal sign here or not. Metana equal sign ekak tibbat neta, we identify values for x, either the function is becoming 0 or undefined. Now in this case, denominator is 1, so there will be no x value that makes the function undefined. There will be no any x value that makes the function undefined because the denominator is 1. For whatever the value that we take for x, function is going to be defined. Function එක define karanna puluwan, explain karanna puluwan. But there are two certain values which makes the function 0. No? If you take this part, what are the values for x that we can take that the product is 0? X equals to minus 3 and x equals to plus 2. එහෙම identify කරාම number 4, mark those identified numbers or values on the number line. On the number line. Now the knowledge of number line is needed. We know when x equals to 3, this is the real numbers line. When x equals to minus 3 and x equals to plus 2, this becomes 0. Again, may dennamata ඕනේ. These are the margins or the limits. For any inequality question, this is how you have to do. Make one side 0, factorize the other side fully, identify values such way that identify the value for unknowns such way that the function is 0 or undefined. 0 or undefined. Then mark those identified values on the number line. We know that this function has a possibility to become 0. No? Equal sign is there. Which means when x equals to 2, 2 minus 2, 0, 0 times anything is 0. Function becomes 0 when the x equals to 2. Then I can highlight it, I can take it. In case equal sign is not there, then this 2 is not included, we can't highlight it, right? Why? When we substitute 2, function becomes 0. We can't take the function 0. That's why I'm not highlighting it. Since in this case we have an equal sign, අපිට සිද්ධ වෙනවා මේක highlight කරන්න, because 2 is also included, 3 is also included. Is that all? Now we have to check 3 regions. One region is this, the other one is this, the other one is this. Values less than -3, values between -3 and +2, values greater than +2. For values in these ranges, what happens to the inequality? We need what? This to be equal to 0 or greater than 0, no? Equal to 0 or greater than 0. When x equals to -3 equals to 0, when x equals to +2 equal to 0. Equal to 0 situations identified. Now we have to check in for what range of values or for what values of x this function is positive. More positive when කාටද කියලා බලන්න ඕන. So greater, less than -3, in between -3 and 2, greater than +2. You have to check for what range of values for x. The function is positive. Below -3, you can take any value. I'm going to check here, any value. If Akif wants to take -100, take -100. If Imtaz wants to take -2, -4, take -4. If another person wants to take -7, take -7. No problem. Any value from below -3. So I will take -5. When -5 is added, if I am taking, if x equals to -5, any value from this range, this is how we do the analysis. When x equals to -5, -5 plus 3, the first bracket is a negative answer. Just the sign I want. Value I want the sign, whether it's a positive sign or a negative sign. If I'm taking a value below -3, the first bracket is obviously minus. If I'm taking a value below -3, second bracket is also minus. How about the product? Here multiplication. How about the product? Minus into minus is plus. We need the product to be plus. And this is an acceptable region. Now in between -3 and 2, take any value. You can take -2, -1, 0, 1, 2, or is -3.5, -1.5, any value. Any value. Kammati magulak karagana, no problem. I'm taking 0. Simplification easy. First bracket 0 plus 3, first bracket is plus. Second bracket is minus. Product is minus. But we need the product to be positive. And I make an A. We need the product to be positive, but the product is minus for any value in this range. So you took 0, no? So 0 volt and make. Can't we take any other value? Take 1. 1 plus 3 plus. 1 minus 2 minus. Product is minus. Take -2. -2 plus 3, -2 plus 3 plus. -2 minus 2 minus 4 minus. Plus into minus minus. Own value එකක් ගන්න. This is the answer. Any value in this between this range. Greater than 2. You can take 3, 4, or 100 or any value. If I take 3, first bracket is plus. Second bracket is also plus. Product is plus. We need the product to be plus, and this is also accepted. To satisfy this inequality, how many x ranges are there? X is less than or equals to -3. I'll write like this. X is okay. I'll write like this. X is less than or equals to -3. That is one range. Comma. And x is greater than or equals to +2. Why equal sign is there? Because when x equals to -3, function becomes 0. 0 is accepted. When x is less than or equals to +2, when x is 2, function is 0. 0 is accepted. X is greater than or equals to 2, less than or equals to -3. These are the two ranges. Or how we can present this answer in another way. Make එක විදිහක් answer එක ලියන. The other way is x is මෙහෙම ලියන්න. You see, we can write like this. X is less than or equals to -3. You see, x is greater than negative infinity, less than or equals to minus 3. Make a range. Okay. And what's the other range? X is greater than or equals to plus 2. From the other side, we don't have a margin, can go till infinity, so less than infinity. There are two ranges. Both ranges values are accepted. No. I'm writing this one, not the other notation. A notation is going to set notation. This is another way. Or you can write like this. X is an element from negative infinity to minus 3. Or we have another range, minus 2 to positive infinity. We can present the answer in any way. If you ask me what way they will give marks, whatever the way you like, you write it. I just wrote all three methods for your reference because exam mona vidihata data deyida. I don't know how they are going to give you the probably they are not going to make the inequalities question complicated. So obviously easy understandable but you should understand, you should know the ways of writing the inequalities, right? So this is how we solve. So checking the ranges of values is very important. Note it's better to take this note, right? And then try the third example. Try the third example. Try the third example. Online students should message in the chat box. I need individual responses. All good, understood. I need individual responses. Quickly drop a message in the chat box, guys. Next example. The tute. You take a next example. Try I will write it on the board if you don't have the tutes with you. I send the tute PDF in the chat box. I will send it again. Before that, example 3. X minus 2 is divided by 2x plus 1 greater than 1. Go through the steps and do it. First thing, make one side 0 and factorize the other side fully. And then after that, identify the values that makes the function 0 or undefined. When it comes to fraction, algebraic fraction, function become algebraic fraction. Algebraic fraction format, if you have a function becomes 0 when the numerator is 0. Function becomes undefined when the denominator is 0. So we discuss those conditions in polynomials and quadratics also, right? So this is going to be a quick recap on that. So we'll do this and then making exercise Kerala, we'll take a 15 to 20 minutes break. After that, modulus functions පටන් අරන් ඒකත් ඉවර කරොත් පුතා 25 marks වැඩක් done. So next Tuesday we'll be discussing sorry, this is positive 2 plus 2, my bad, it's plus 2. Next Tuesday we'll be doing this one මොකද්ද මේ partial fractions and logarithms. Next Tuesday we'll be discussing partial fractions and logarithms. And partial fractions ඉගෙන ගත්තයින් පස්සේ අමතක කරන්න එපා පුතා, because we are going to use partial fractions again in integration calculus. හෙට ඉගෙන ගත්තයින් පස්සේ තව මාස 3කින් පස්සේ තමයි we are going to use partial fractions. So since you guys are සමහර ළමයි ආල්වස partial fractions කරන්නේ නැද්ද කියලා අහලා තිබ්බා. That's why I'm doing partial fractions. But usually in my classes, I do partial fractions in the middle of integration when it is needed the most. Right, here see. Now we need to make one side 0. So I'll subtract 1 from both sides. So I will get x minus 2 is x minus 2 over 2x plus 1 minus 1 is greater than 0. Now here clearly the equal sign is not there. Is it fully factorized? Not yet. Fully factorized when I will have to take a common denominator and simplify this algebraic fraction. So we get x minus 2 over 2x plus 1 minus, what's the common denominator? 2x plus 1. 2x plus 1 over 2x plus 1 greater than 0. Now take a common denominator. Common denominator is 2x plus 1. Here we have x minus 2 minus 2x minus 1 greater than 0. Right? X minus 2x is minus x, minus 2 minus 1 is minus 3. So this is minus x minus 3 divided by 2x plus 1 greater than 0. So take a minus outside from the numerator. Fully factorizing means fully minus common nang ewath ganda eliyata. Take fully outside. So minus means minus 1 no. I'll just keep the minus sign times x minus 3 divided by 2x plus 1. 2x plus 1. Denominator, there is nothing else to factorize. No? With the common factors, nothing is there. Is greater than 0. Sorry, 2x plus 3 is x plus 3. Ne? I'll come to that part. That's a good question. Right? Right. So we simplified like this. Now there's a question. I was about to come to that part. You asked me. Then prashnayak තියෙනවා. Sir, can't we directly x minus 2 divided by 2x plus 1 and multiply both sides by 2x plus 1 and simplify this? මේක කරන්න පුළුවන් බැරිද? Can't. That's why I told you we have to simplify and make one side 0 by a logical way. මෙහෙම කරන්න බෑ. We always take and simplify as an algebraic fraction. මෙහෙම කරොත් මොකෝ වෙන්නේ? 2x plus 1 cancelling out. X minus 2 is greater than 2x plus 1. You will after that take all the terms to one side, and what you will do? Here take all the terms to one side. 0 නැත්නම් minus 2 තියන්න. And take subtract 1 from both sides, minus 1. Subtract x from both sides. This becomes 2x minus x. So this gives you x is greater than minus 3. ඔහොම answer එකක් එයි. But the thing is, this is not the range. මේක වැරදි. You will get a different range here, okay? Sometimes coincidentally හරියන්නත් chance තියෙනවා. That's in a very rare case. That's in a very rare case. But here we have to take this one or subtract 1 from both sides, take a common denominator, simplify as an algebraic fraction. The reason is, in here, you forgot the impact of this denominator. What if the denominator is 0? Function is undefined. Denominator is 0, no, function is undefined. So you're multiplying both sides with 0 and you're getting an answer. This is wrong. So remember, when it comes to algebraic fraction inequality, you have to take all the terms to one side and simplify as an algebraic fraction to get the answer. Now, after fully factorizing it, identify the values for unknown term that makes the function 0 or undefined. Remember, function becomes 0 if the numerator is 0. Function becomes undefined when the denominator is 0. Function is 0 when the numerator is 0. Function is undefined when the denominator is 0. If you can't remember that idea, just write it and keep it. Function becomes 0 when the numerator is 0. Function is undefined when the denominator is 0. So if I want to find the values for x such way that the function is 0, then you need to identify x values such way that the numerator is 0. Numerator is 0 when x values here, what I get the values such way the function is 0. Denominator 0 when if you take x values, you will get the values for x such that the denominator is 0. So now, if I take x equals to minus 3, you see, when x equals to minus 3 plus 3 is 0, numerator is 0, 0 divided by anything is 0. Anything is 0. Again, on the number line, minus 3 is one answer, which makes the function 0. Identify the values that makes the function 0 and function undefined and mark those identified values on the number line. Mark those identified values. What values? Values such values we identify such that the function becomes 0 or undefined. What value makes the function undefined? The denominator 0, no? Denominator 0 when for what x value? Minus half. If you substitute minus half here, 2 and 2 cancelling out, minus 1 plus 1 0, no? Minus half. Minus half is bigger than minus 3. In a minus half. This is the real numbers line, actually in this case unknown value, which is x's line. Then what's the idea? What's the idea now? After identifying these values, obviously function is not equals to 0, so 3 is not considered. So we cannot highlight like in the previous one. Here we can't highlight it. Here function becomes undefined when x equals to minus half, then obviously this cannot be taken. Function ekak undefined when value ekak aragena thirimanne naha ne. Taking a value that makes the function undefined, it's useless. So no need to consider that. Then take values below minus 3, in between minus 3 and minus half, greater than minus half, and check, is this complete product is positive or not? Mona range the positive win. Now I will take in this range. I'll take in this range less than minus 3. Less than minus 3, any value you can take. Let's take minus 4. Let's take minus 4. If you take minus 4, here see puta, this minus sign is by default outside. This minus sign is by default outside. By default, we have a minus. If I'm substituting minus inside the bracket, a value that is less than minus 3, which is minus 4 the bracket is also going to be minus, divided by less than minus 3. If I substitute a value, let's say minus 4 or minus 5 or something, denominator is also 2 times minus 4, minus 8 plus 1, again minus. The entire product is what? Minus divided by minus is plus, minus times minus is plus, plus divided by minus is minus, the product is minus. We need the entire simplification to be positive. This is not an accepted range. In between this, you can take any value. I'll take minus 1. This is a by default minus. If I substitute minus 1, this is plus, divided by, if I substitute a minus, this is going to be minus 1. This is also going to be plus, no? Sorry. Minus. This is going to be minus. Substitute minus 2, minus 1, anything. Minus 1 substitute, make it minus. Minus 2 substitute, make it minus. The entire product is plus. Minus into plus equals to minus. Minus divided by minus is plus. So we need plus, it is accepted. How about this? This is minus, greater than minus half if you substitute a value. Let's take 0 this is plus. This is also plus. Right? Make it plus. 0 make it plus. This is minus. If you substitute a value, let's say minus half, greater than minus half, you can take 0. You can take plus 1. Anything. This is by default minus. This is going to be plus. This is also going to be plus. Minus into plus equals to minus. Minus divided by plus is minus. Take a minus. Therefore, this is also not accepted because we need it to be plus. What is the range? X is greater than minus 3, less than minus half. See, if you do it the other way, you'll get x is greater than or less than minus 3. You will miss the other part. Right? Make them a hurry maker. Or you can write it as x is an element where minus 3 to minus half. Left to right only we write. We can write it from left to right. This is how we do it. Right. So I will send the tute again in the chat box for online students. In exercises, do these questions that I'm marking. ඒ ටික විතරක් කරන්න. Right. I send the tute. So in exercises, first 3 questions are like easy, no? Amaru yolimma patangamu. Do question number 6. In exercises, do question number 6. Online students, just write them down. You have that. I send the tute in the chat box, so you can refer to those question numbers. In page number 4, exercises, do question number 6 and question number 10, and then again question number 14, 6, 10, 14. Question number 9, 6, 9, 10, 14, 6, 9, 10, 14. First of all, mark them down. Na make makanne. Keep this aside and first of all mark down the question numbers. After that, I chat box එකේ දාන්න. Please someone send me the question numbers කියලා ආලා දාන්න. Listen and mark the question. 6, 9, 10, 14, 18, 6, 9, 10, 14, 18, 21, 21, 25 and 26. 21, 25 and 26. So we have 6, again 6, 9, 10, 14. ඊට පස්සේ again I said 21. 21, 25, 26. In between that, some other complicated questions also there. ඒව ඔයාලා try කරන්න. Okay. So to discuss the idea of inequalities, I will do this because the main part is modulus functions. අපි ඉක්මනට ඒකට යන්න ඕන. So there are 1, 2, 3, 4, 5, 6, 7 questions are there. So I'll give you 10 minutes until 10. Quickly do them. Quickly do them. I'll give you 10 minutes, do them. Until 10:30 we'll discuss it and then we'll take a 20 minutes break. ඊට පස්සේ modulus functions idea එක discuss කරලා ඒකේ graphs part එකට ගිහිල්ලා past papers යන්න. Right? Quickly finish it. ටගල කරන්න. within those example questions that we are about to discuss now from exercises. One questions telling Puta from inequalities, whatever the types of questions that they can ask in final exam will be covered. Okkoma types tika cover වෙනවා. Right, okay. Now let's discuss in exercises. Question number 6 in 6 again 7 minus 3x is less than or equals to minus 2. 7 minus 3x is less than or equals to minus 2. This is actually not any of the questions that I made or anything. Make most of the students in Sri Lanka refer karana එක lecturer කෙනෙක්ගේ reference book එකකින් ගත්ත questions ටිකක් හරි. But when it comes to modulus functions, all the questions are මගේ නෙවෙයි ඒවා past papers. Those are past papers. The best questions you can find is past papers. Right. Now, 7 minus 3x less than or equals to minus 2. Here's a yeah. We need to first of all, in this case, this is a normal simplified one. No, the method of factorize karla analyze karana there is nothing. No. So first of all, we'll do like this. I will add plus 2 to both sides. We get 7 minus 3. You can do it at once. Just to show you the steps, I will do like this. This becomes 0. So 7 plus 2 is 9. Add plus 3x to both sides. 9 minus 3x plus 3x less than or equal to 0 plus 3x. So this gives us 9 is less than or equals to 3x. Divide both sides by 3. Divide both sides by 3. We get 9 divided by 3 is less than or equals to 3x divided by 3. Where x is greater than or equals to, maybe the greater than or equals to 3. Right? X is greater than or equals to 3. That's it. That was the easy question. Question number 9. 9 now everyone stop working and listen. 5 is less than or equals to 1 plus 2x. Stop working and listen. Nah? Less than or equals to 6. Shall I reduce the AC a little bit? Heat right. Now, if you get double inequalities like this to solve, remember this method. Double inequalities to solve. Then take this part as one set and these two as another set. 1 plus 2x is less than or equals to 6. These two as one set, these two as another set. Okay. Now solve this one as usual. Subtract 1 from both sides. 5 minus 1 is 4. Less than or equals to 1 plus 2x minus 1 is 2x. Divide both sides by 2. You get 2 is less than or equals to x. Simplify this one. Subtract 1 from both sides. You get 2x less than or equals to 6 minus 1 is 5. Divide both sides by 2, you will get x is less than 5/2. Are these two the answers? No, Puta. This is a continuous inequality. Then in such case, you have to mark them in the number line. This is actually the x-axis, not the x-axis, the real numbers line. X is the unknown in the x kilo mark karanat puluwan. Or you can x is in real numbers kilo mark like this, or just real numbers kilo mark karat, no problem. Right. Here we have 2. Here we have 5/2, which is 2.5. So I'll take 2 somewhere here, 2.5 somewhere here. Both inequalities, we have equal sign. So 2 is accepted. We have an equal sign. 2.5, which is 5/2, is accepted. Now mark this range. X is greater than or equals to 2. No? Greater than or equals to 2 can මෙන්න මේ පැත්ත. X is less than or equals to 2.5 means මෙන්න මේ පැත්ත. Now both inequalities together. Then what's the accepted region? The common one. The common one. This is just a rough work. You can do it in your answer script, answer sheet එකේම කරන්න, no problem. ලකුණු නෑ මේකට. But still you can do it like ඔය වැඩේ කරන්න, no problem. So the for this inequality, the range of values for x is greater than or equals to 2, less than or equals to 5/2. If you write it another way, what's the other way? X is an element 2, 5/2. Since we have the equal sign, I have to put the box bracket, right? Okay. If there is something to write down, quickly write it down. Right. Next one is already factorized now. X minus 5 times x minus 2 is less than or equals to 0. Okay. Now here see. What is the idea? When there's a algebraic expression, now these are linear functions. Easy to simplify. This one is not a linear function. This is a quadratic function which is already factorized. If it is not number one, if not both, if one of the sides are not 0, you have to make it 0 logically. Next, factorize the other side fully and identify values for the unknown, in this case x, such way that the function is 0 or undefined. In this case, undefined means nae kohe tawat. So function is becoming 0 when x equals to 5 and 2. When x equals to 2, function becomes 0. When x equals to 5, function becomes 0. Right? You mark it as real numbers line. You mark it as x's values or as x line, or as you can mark it as x is in real numbers kila mark karanna puluwan. No problem. Anyway, right? Mama x kila danta daganna. Right. And we know that when x equals to 2, 2 minus 2 is 0. 0 times anything is 0. This becomes 0. Equal sign means 0 is accepted. This 2 is accepted. When substitute 5 minus 5 is 0. 0 times anything is 0. This equal sign means this 0 is accepted. 5 is accepted. Now we have to check 1, 2, 3 ranges. Below 2, you can take 1, 0, minus 1, or as 1.5. Decimal values also can take. Any value you can take. Let's take 0 for simplifications purposes. First bracket is 0 minus 5, it's minus. 0 minus 2, minus. Product is plus, but we need the product to be negative. So this is not accepted. Method. Take 3 or 4 or 2.5 or 3.5 or 3.9, any value. First bracket is minus. Second bracket is plus. Product is minus. We need the product to be minus, and this is also accepted. This range is accepted. Above 5, first bracket is plus, second bracket is also a plus, product is plus. This is not accepted. එහෙනම් මට ගන්න පුළුවන් x is greater than or equals to 2, less than or equals to 5, or you can write x is an element 2, 5. Box bracket දාන්න because we have the equal sign on both sides. Then ඉතින් පුතා after this, since you have completed quadratics also, now you can teach an O-level student a full graphs question properly. උඹලා හරියට ඉගෙනගෙන තිබ්බනම්. Right? Now see value. O-level syllabus is what? A-level හරියට කරපු මනුස්සයෙක්ට O-level can teach. But you should have a proper qualification if you're starting teaching. In my perspective, if you want to teach O-level maths, at least university first year wat indona in the relevant field, engineering or physical science, maths related field එකක indona. If you are teaching A-levels, campus එකේ second year third year wat indona, එහෙම නැත්නම් degree holder කෙනෙක් වෙන්න ඕන. Otherwise you don't know the maths properly, no. Right? එහෙම නැත්නම් කොහොමද උගන්වන්නේ? Not 11, 14, no? Next, I asked you to do 14. Now listen, 14.1 is a quadratic expression, x squared minus 2x minus 15. We can easily factorize that, no? You don't have to show the factorization steps. Factorization steps showing that is not not needed. Okay, not needed. If you want, you can do it, but it's time consuming, no? So directly factorize it. X squared minus 2x minus 15. 15 can be taken as 3 times 5, so minus 3, sorry, minus 5 plus 3. So the factors are x minus 5, x plus 3. On number and double check x squared plus 3x minus 5x minus 2x minus 15. Yeah, these are the factors. So you identify values for x such way that the function is 0 or undefined. This is not becoming undefined because the denominator is 1. There is no impact of x to the denominator. So no, function is not becoming undefined. So when the function is becoming 0, when x equals to minus 3 and plus 5, no? මේවා හරියට mark කරන්න the positions. That's why in the beginning එක value එක greater than b නම් කොහොමද mark කරන්නේ ඔතනින් පටන් ගත්තේ to mark these ones properly. If you don't, if someone is marking 5 here and minus 5 minus 3 here, වැරදි ඉතින්. Right? You will not get the correct answer. So this is minus 3, this is 5. Okay, right. So there is no equal sign here. So 5 is not accepted, minus 3 is not accepted. Why? Function cannot be 0. Function cannot be 0 means these two places won't come. Now, less than minus 3, you can take minus 4, minus 5, anything. First bracket is minus. Second bracket is also minus. Product is plus. We need the product to be plus. This is accepted. In between this, you can take any value. I'll take 0. Simplification is easy. First bracket is minus, second bracket is plus, product is minus. But we need the product to be greater than 0 means plus. So this is not accepted. Greater than 5, let's take 6 or 7 or any other number. First bracket is plus, second bracket is also a plus, product is plus. Now this is accepted. And x has two ranges. X is less than minus 3, greater than negative infinity. Okay, comma, x is greater than 5, less than positive infinity. You can write like this. Or you can write x is an element minus infinity to minus 3 union 5 comma positive infinity, like this. You can write like this also. Can see, no? Akib, can't see. Right. Next, question number 21. 18 I asked you to do. I asked you to do 18. 18. X plus 1 times x minus 3 less than x times x minus 1. Less than x times x minus 1. Now here, you can't divide both sides with this one. Na? Divide karanna bad. Multiplication divisions can't do. What you have to do? Subtract. Idea in the beginning of inequality, what's the definition of inequality? If something is greater than another thing, this implies this. They should, if you can divide both sides by this, then they should have given mehema denna tibbane. They didn't give the definition like this. They gave the definition. If the inequality is this, we can do this. If the inequality is this, then we can do this. Then x plus 1 times x minus 3 is less than x times x minus 1 now. This happens when x plus 1 times x minus 3 minus x times x minus 1 is less than 0. Now remove the brackets. X squared minus 3x plus 1x minus 2x minus 3 minus x squared minus into minus plus plus x less than 0 plus x squared minus x squared cancelling out. So we get minus 2x plus x is minus x minus 3 less than 0. Take a minus outside, minus times x plus 3. Simplify karanna. Add plus 3 to both sides, you get minus x is less than plus 3. Divide both sides by minus. We know that when we divide with the minus value, sense changes. Eka theorem we studied, no? When we divide with minus, we get x is greater than minus 3. Sense changes. There is nothing else to do in this. This is an important idea. Some students, what they do, they divide. They divide both sides by x times x minus 1 and try to do this one. We have to go with the definitions. Definition එකත් එක්ක යන්නේ. Right, now we have 1, 2, 3 more questions. Quickly finish them, and then after that we'll take a break and come. After this, Monday physical batch students, class I'll be taking the class today, right? And then after your class again 26 A level pure maths class is there tonight. Right. Question number 21. X minus 1 over 2x plus 1 is greater than 1. Again, multiplications, divisions can't do. What you have to do is subtract 1 from both sides. Go with the definition. Here, again the same idea. If something is greater than another thing, this can happen when this one is greater than 0. A definition use karanne. Right? So subtracting 1 from both sides, x minus 1 over 2x plus 1 minus 1 is greater than 0. Take a common denominator. Make same example instead of minus 1, minus 2 in example number 3 I did, no? So I'm not going to do this. This is similar to example 3, yeah? So you do it. similar to name, exactly the same, only instead of -1 we have -2. So I'll directly move on to the next question, 25. I'll do the 25th question. Question number 25. 2x minus 1 over x plus 2 is greater than 2x plus 1 over x plus 3. Remember, doing the cross multiplication or multiplying both sides with x plus 3, dividing both sides with 2x plus 1, if a value is greater than another value, then bigger value minus a smaller value is greater than 0. මෙන්න මේ idea එක. If a is bigger than b, a minus b is bigger than 0. That idea only we can use. Or the other idea, if a is smaller than b, a minus b is smaller than 0. In a idea එකෙන් තමයි ගන්න ඕනේ. So I can make one side 0 like this, 2x minus 1 over x plus 2 minus 2x plus 1 over x plus 3 greater than 0. Now take a common denominator, we get 2x minus 1 times x plus 3 minus 2x plus 1 times x plus 2. Common denominator is x plus 2 times x plus 3. That's taking a common denominator and simplifying the algebraic fraction, okay? Right? Now remove the brackets, 2x times x, 2x square, 2x times plus 3 plus 6x minus 1x plus 5x. Minus into plus equals to minus 3. Minus, I'll put a bracket first, 2x times x, 2x squared, 2x times 2, 4x, 1 plus 1 times x plus 1x plus 5x. Plus 1 times 2 is plus 2. Divided by x plus 2 times x plus 3 greater than 0. Now I can see when I remove the brackets, minus 2x square plus 2x square plus 5x minus 5x cancelling out. Minus 3 minus 2 minus 5. In the numerator we have minus 5. The numerator we have minus 5. Simplify and check. Numerator we have minus 5 divided by x plus 2 times x plus 3. This is greater than 0. Now fully factorized. Fully factorized. There is nothing else we can do to do the factorization. No? Fully factorized in the sense fully factorized when known. Okay. This is not fully factorized. Why? It's still as an expression. If you don't know what is the idea of factorization, what's the idea of factorization? An expression is written as a product of some things. Now, මෙහෙම ගත්තොත් x squared plus 1, this is not factorized. Make a factorize කරන්නත් බෑ. Okay? This is not factorized because it's a sum of two expressions, sum of two terms. Factorize කියලා කියන්නේ x minus 1 times x plus 1. The expression is written as a multiplication of two or more things. Continuous multiplication එකක් විතරයි වෙන්න ඕන. Then only we say that it's a fully factorized thing. For an example, someone is having x squared minus 7x plus 12 plus 3. May part take, if you factorize it, you get x minus 3, x minus 4. This one, if you take this part, if you take, it is x minus 3 times x minus 4 plus 3. If you ask me, is it fully factorized? No, it's not factorized. Make a method had factorize කරන්නත් බෑ. If you want to fully factorize it, then 3 method to add karla, then you have to think of the factorization. 12 plus 3, 15. Then x squared minus 7x plus 15 will factorize karanna by completing the square or any other method. This is not factorized. Factorized na continuous product only. Now in this case, numerator, all x terms cancelled out. So there is nothing to factorize in the numerator. Denominator fully factorized. No? Now we have to, after fully factorizing, what's the idea? Identify values for the unknown such way that the function is 0 or undefined. In this case, function 0 when the value is there. So we have x values where the function is undefined. When x equals to minus 2, function is undefined. When x equals to minus 3, function is undefined. Minus 2 is bigger than minus 3. Yeah? So this is the x values. Equal sign is not there. Equal sign is tibbat. Even though the equal sign is there, this 3 and minus 2 won't come. Why is that? Because these two values not making the function 0. Those two values making the function undefined. Methana equal tibunat. Even though the equal sign is there, these two won't be considered. Why? That's not making the function 0. That makes the function undefined. Why? That makes the denominator 0, not the numerator 0. Right? So even though the equal sign is not, even if the equal sign is there, we cannot consider these two as values in the range. Now below minus 3, if I take minus 4, numerator minus 5, obviously a minus value, divided by, if I take a minus value below this one, first bracket is minus, second bracket is also minus. The entire product is minus, no? The entire product is minus. Entire product is minus. Minus divided by minus into minus plus, minus divided by plus is minus. But we need the entire product to be positive, and this is not accepted. In between this minus 2.5, numerator is obviously minus. No impact of x. Denominator, this bracket is minus, the other bracket is plus. The product is plus. Accepted. Because it needs to be positive. Minus 1, 0, anything. Numerator is obviously plus. Denominator, 0 plus 2 is plus. The entire product is minus. But we need the product to be positive. This is not accepted. Therefore, range of values satisfies these inequalities. X is greater than minus 3, less than minus 2. If you want, you can write the other inequality also. I mean, solution, right, as other answer also here, minus 3, comma minus 2. That is equal sign is not there, so parenthesis. Right. Last question. Inequalities part taker with this question fully done, and then we have to discuss modulus functions. Now 7:30 started the class, 3 hours for inequalities. It was 11 after the break, somewhere around 10:50 I'll be starting the modulus functions. Eka 2 විතර වෙනකන් යනවා, 2:30 එකත් එක්ක modulus functions also done. Okay, right. Question number 26. Usually morning වැඩ කරද්දි පට්ට වැඩ ගොඩක් කරනවා. Now 3 hours ඇතුළත ලොකු වැඩක් ඉවරයි, because usually පුතා morning hours means your brain is free. ටක් ගාලා understand කරගන්නත් පුළුවන්. Right. We have 6 times 3x plus 1 divided by x minus 1 times x minus 2 times x plus 3 is less than 1. This is a cubic function. Simplification එක වැඩි. Here in this case, we have a big simplification. 6 times 3x plus 1 divided by x minus 1 times x minus 2 times x plus 3 minus 1 is less than 0. The thing is, we have to take a common denominator and simplify. We get 6 times 3x plus 1 minus x minus 1, x minus 2, x plus 3. Common denominator is x minus 1, x minus 2, x minus 3, less than 0. Less than 0. All right. Now we'll have to remove the bracket. This is 18x plus 6 minus, inside the bracket simplify. X is, first of all, I'll expand this. X squared minus 2x minus x minus 3x plus 2 times x plus 3. Again, simplify this one. Mama simplify karlama liyanna. Or as we'll write in the next step. X minus 1, x minus 2, x minus 3 less than 0. Right. Shall I erase this side, Puta? Online. Shall I erase this part? Okay. Drop message in the chat box. Everyone, shall I erase this part, online students? Huh? Right. Okay. So we get 18x plus 6 minus x cubed plus 3x squared. It was say minus 3x squared minus 9x plus 2x plus 6 divided by x minus 1, x minus 2, x minus 3 is less than 0. Right? So we get plus 3x squared minus 3x squared cancelling out. So we get 18x plus 6 minus x cubed minus 9x plus 2x minus 7x minus into minus plus no plus 7x plus 6 divided by x minus 1, x minus 2, x minus 3 less than 0. Sorry, minus 6. This is minus 6. So we get minus x cubed plus 18x plus 7x plus 25x minus 6 plus 6 cancelling out 0 divided by x minus 1, x minus 2, x minus 3. Good time 6 cancel out. 6 නිකන් හරි cancel out උන්නේ නැත්නම් remainder theorem use factor theorem use කරලා factorize කරන්න වෙනවා. Right. So take x as a, I will take minus and an x as a common factor outside. If I take x minus x outside, you see, listen now. If I take minus sine and an x outside, x squared make a minus 25. You know? We can nicely factorize it, no? Right. Question again, Arabic system. Right. So we can further factorize it minus x minus 5 times x plus 5 divided by x minus 1 times x minus 2 times x minus 3 less than 0. Right. We don't have anything else to factorize. Done. Then Buddha, identify values that makes the function 0 or undefined. X. We know when x equals to 1, 2, 3, which makes the function undefined. Right? X equals to it's given as plus 3. Plus 3 වලින් නෙමෙයි දරන් තියෙන්නේ. Plus 3 තමයිනේ. මෙතන plus 3 කියලා අරගෙන ඕකේ නෝ simplification හරනේ. මේක plus 3. මෙතන වරද්දලා තියෙන්නේ. Simplifications වැරදි නෑ, good time. Okay. Right. So we have here, see, when x equals to plus 1, function defined and function becomes undefined. When x equals to plus 2, function is undefined. When x equals to plus 5, also function is undefined. And then when x equals to minus 3, function is undefined. When x equals to minus 5, function is 0. Since the equal sign is not there, then 0 when a places I can't take. Here, this place also I can't take. And then plus 5 also I can't take. Undefined places කොහොමත් ගන්න බෑ. So these places also will not be highlighted. Then වැඩේ කියන්නේ මොකද්ද? You'll have to check 1, 2, 3, 4, 5, 6 regions. අනේ පුතා check කරලා ranges ටික අරගන්න. I'm not going to do it. Right? 6 ranges. I have done the other ones. No? ගාන්න කල්පනා කරලා take them here. Here we have a minus, including this one you have to consider, okay? This is a by default minus. Okay. මම එකක් කරලා පෙන්නන්න. I'll do one range and show. I'll take a value below minus 5, minus 6. This is a by default minus. Here see ya. මම මෙතන check කරන්නේ. We have a by default minus. And then x also substituted as minus here. Minus below minus 5 means x is a negative value. This is a by default minus. This is that x. And then x minus 5 is minus. X plus 5 ekat minus 1 because I'm taking a value below minus 5. Divided by, here this becomes minus. This becomes minus. The other one is also minus. Minus into minus into minus into minus plus whenever. Minus into minus plus, plus into minus equals to minus, plus divided by minus. The entire product is minus. Take a value in between this. Check like that. Don't forget that this is a by default minus. X or the substitute karna value ekේ sign එක here. This is by default minus. This is that x's minus. Here also if I'm taking a value, both are the same thing, right? So check for the ranges and get the values. I'm not going to do that, right? ඔයාලා කරන්න ඒක ලස්සන්ට. Right, now it's 10:33. Let's take 10:35 කියලා to write 2 minutes දෙන්න. You can take a break until 10:50 වෙනකම් break එකක් ගන්න. Modulus functions I'll be starting at 10:50. So you can take a break. Okay, 10:50 I'll be starting the modulus functions. Right, take a break and come. It's 27. Huh? Off pannikonga. Right, online students, are you guys there? Drop a message in chat box if everyone is back. Right. Hari. Great. Now, let's move on to the next part, which is going to contribute a greater marks in your short questions paper, modulus functions, right? Or else piecewise functions, right? Modulus functions and the piecewise functions. සිංහලෙන් කියන්නේ මාපාංක ශ්‍රිත. තව එකක් තියෙනවා කඩමණි ශ්‍රිත කියලා නම කැතයි ඒ නම. Right, piecewise functions or modulus functions. Right. Write the subtopic introduction. Those who have the tute can complete in the tute. Those who don't have the tute and the PDF files, till you get the tute, ඔයාලා note එක වෙනම අරගන්න. Write the subtopic introduction. Introduction. Right. ලියන්න absolute value of a real number. ලියන්න absolute value of a real number. Right. Write the definition below that. Write the definition below that. In introduction, manage a space. Under introduction, first of all, we'll discuss about absolute value for real number and then modulus functions. Right. Absolute value of a real number. Yeah, absolute value of a real number. Right. The distance from the absolute zero, 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 the distance from the absolute zero to the position of the number, to the position of the number on the number line, on the number line, on the number line, is referred to as the absolute value of the real number. Is referred to as the absolute value of a real number. Absolute value of real number. For an example, if you are taking absolute value of number 5, it means on the number line, okay, on the real numbers line, from the 0, that's what we call the absolute 0, to number 5, to 5's position, the distance is the absolute value, which distance is 5, right? This is absolute value of 5. Absolute value of minus 5. If you are taking absolute value of minus 5 from 0 to the minus 5, if you measure the distance, the length of the straight line joining the 0 and the point on the number line, basically the distance from 0, still 5 units. Still it's 5 units. Right. So we can discuss so many examples. I'm not going to discuss for everything. This example is enough, numerical example. We generally discuss. If it is a number generally given like this, A is a real number. We don't know whether it's positive or negative or 0. This one's absolute value is defined like this. If it is a positive number, it returns the same answer. If it is a negative number, it actually returns what? Minus times the number. No? If it is a negative number, actually it returns the minus times itself. Minus times itself. If it is absolute value of 3, 3 returns 3 itself. If absolute value of minus 3, it returns minus times minus 3. Absolute value of a positive number, there are two instances, no? So also, if it is 0, 0 returns that one itself. If it is a number generally given like this, I don't know whether it's a positive number or a negative number. If it is a positive number or 0, positive means greater than 0, equal to 0. Give me a minute. Right. Either positive or equals to 0, because positive number also return itself, 0 also returning itself. 0 means absolute value of 0 itself. If the number is positive or 0, it's returning that number itself. If the number is a negative number, minus 5 or minus 3 or minus 2 or something, it's returning minus times that number. If it is A is minus 3, minus times minus 3. If it is minus 2, minus times minus 2. So here we take the situation or the case, here we write the result. Absolute value of a real number is given by this definition. What's the definition? It returns the same value if it is positive or equals to 0. It returns the minus times that value if it is negative. This is the absolute value of a real number. Right. Now, if we specify these two, okay, specify to functions. If we specify this to functions, absolute value of a function kila kiyanne puta, same idea. There are two definitions, same as real numbers. Functions wala same thing, okay, same thing. Function is either positive or 0. If the function is 0 or positive, it returns the same value, same function. If the function is negative, it returns the minus value of the function. If the function is negative, it returns the minus value of the function. For an example, let's say we have a function modulus of x plus 1. We have a function x plus 1. And we are considering this is the modulus function. Fx is the function, modulus is the its modulus function. We have two definitions. What is it? We don't know whether it's strictly positive or strictly negative or zero. Then we have to consider both the situations. If this function is greater than or equals to 0, greater or equals to 0, it returns the same function x plus 1. If this function is less than 0, it returns minus times x plus 1. If the function is positive or equals to 0, it returns the same one. If the function is negative, then it returns minus times that value. මේක තමා පුතා defining a modulus function කියලා කියන්නේ. Defining. This is how we define a modulus function. Using this one, we have further simplifications, further calculations. ඒව අපි හිමින් කරමු. First of all, under absolute value of real number, write this example and write this definition for the real number. And specified functions කියලා දාලා do this part. Okay. Remember, modulus functions returns the magnitude. If the function is positive or greater than 0, it returns the same function. If the function is negative, it returns minus times the function. Minus times the function. That's the idea. So write this example also and then write the subtopic, graphs of modulus functions. After writing this, write the subtopic, graphs of modulus functions. Graphs of modulus functions. Actually, modulus functions, puta, not just a one function. Na? When you plot the graph, you have two graphs to plot. Metane a straight line, we have another straight line to plot, like that. So under graphs of modular functions, we discuss two examples, and then we'll move to the ඊට පස්සේ අපි inequalities solving part එකට යන්න. Okay. After that, past papers discussion. ලොකු දේවල් නෑ. Okay. Graphs of modulus functions. Done. ඉසේක දාන්නද ප්‍රශ්නේ? Today the whole day somehow you will have to manage with this, you know. Huh? Not you, you will be leaving ඔයාලට නෙමෙයි අද class එක දෙන්නේ. Right. Right. Under graphs of modulus functions, we'll do an example. Example 1. Example 1. Liana, define and plot the graph of the function y equals to fx equals to modulus of x. Y equals to fx equals to modulus of a graph of the function y equals to fx equals to modulus of x. Do it. Y equals to fx equals to modulus of x, fx. Write this one. Don't do it. Write this one. Listen. Now all of you stop working and listen. When it comes to modulus functions, first thing we have to nicely define it. Y equals to fx equals to modulus of x. Modulus should be defined in two ways. What are the two ways? We have two possibilities, no? Then you have to put a curly bracket like this. When the function is either positive or equal to 0, it will return the same value. If the function is negative, If the function is negative, it returns minus times the value, minus times whatever the function inside the modulus. Whatever the function inside the modulus. So, we have, this is the primary example that I can take, the basic example. Now we have two graphs. What are they? Y equals to x, defined for the region x is greater than 0. Remember the region, na? This graph is valid only for x is greater than or equals to 0 region. And this y equals to minus x graph is valid only for x is less than 0 region. Now we have to find coordinates to plot both the graphs. This is a straight line, this is also a straight line. So having 2 or 3 coordinates is more than 2 is more than enough actually. 2 is minimum requirement is 2 coordinates. So I recommend you to start with this margin. X is great here. There are lots of sensitive things that we are going to discuss now. Don't write anything because some things are not possible to give as a written note. But you have to understand the techniques. My recommendation is, as a good practice, start from the margin value. Margin value is 0, x is greater than or equals to 0. So when x equals to 0, y equals to 0, one value I have. Greater than 0 region is we can take values greater than 1 on greater than 0 only. You can take any value 0.5, 0.9, but decimals ga not a piece. Take a whole number to make your simplifications. That doesn't mean we can consider only the whole numbers. No, we can consider any real value greater than 0. So I will consider 1. When x equals to 1, y is equals to 1. When x equals to 2, y is equals to 2. Like that, we can consider some coordinates. For this one, equal sign is not there, but better to start with the margin. I will tell you why this make a consider just to plot the graph. But since the equal sign is not there, there is a very, very important thing that you have to take into consideration when plotting the graph. When x equals to here, below 0 means minus 1 it can take. Then y is equals to minus into minus 1 plus 1. When x equals to minus 2, y is equals to plus 2. Substituency minus 2 minus 2 plus 2. So we have coordinates to plot both the graphs. Now here's here. When you plot these graphs, you can't use a graph paper or anything because this one comes under short questions paper. You have to answer in the given space. Then you have to take a scale using your ruler. Right? Ruler, scale, straight line scale, measure from that. Okay? Make sure you don't use pens. Not even to mark the coordinates, x, y mark, do not use pens. Because in case if you make a mistake, you can't erase it because you are writing the answer on the question paper itself. You'll have to do it in an additional sheet. Time consuming, time wasting. So, make sure you use only pencils to plot the graph. To plot the graph, use only pencils. 2 coordinates is more than enough, okay? But I'm taking 3 coordinates just for the betterment. Right. Here we have the x-axis, normal coordinates plane only, special coordinates plane name water, y-axis and origin. X coordinate 0, 1, 2, 3, like that we can mark. Make sure that you take the same gap. Same gap on the negative side, minus 1, minus 2, minus 3, minus 1, plus 1, plus 2, plus 3. I usually, when I was doing these things, I usually take 1.5 centimeters or 1 centimeters for 1 unit. If you have small number of values, then better to take 1 centimeter. So 1.5 centimeters. If you have bigger values, then take 1 centimeter, right? So it's just to give you a rough idea. Right? When x equals to 0, here we have the equal sign, which means x can take 0 for this graph, right? You have to be very conscious about that. Here we have the equal sign for 0, which means x can take 0 for this graph. We have a coordinate, right? When x equals to 1, y equals to 1, we have another coordinate here. When x equals to 2, y equals to 2. Here we have another coordinate here. Since x can take 0, y equals here. Since x can take 0, y equals to 0 is accepted. So you can start from 0 itself. This is y equals to x graph. You can ask me, so can't we plot below this? Can't. Why is that? This graph is valid only for above x region, above 0 region, greater than or equals to 0 region. Below that, may the graph part of the graph is there, but in this case, it's not valid. That area is not valid. It's restricted for the this part. How about the other graph? When x equals to 0, y equals to 0 only, but can it accept? Is it accepted? No. 0 here, x cannot be 0, so x can't take 0. I'm taking x equals to 0 just to understand a coordinate. But actually that coordinate is not on the straight line, no? Why x is not equals to 0. Equal sign is not there. Next one, when x equals to minus 1, y equals to plus 1. X equals to minus 1, y equals to plus 1. X equals to minus 2, y equals to plus 2. Now, when joining here, x cannot be equals to 0, but 0 ළඟට යන්න පුළුවන් නේ. X is less than 0. Less than 0 means minus 0.000000001 is possible to accept. Can 0 එක ගන්න බෑ. Can't take 0, but can go closer to 0. To imply that idea, we keep a small gap with this, very small gap, not a visible but not visible වගේ. Visible but not visible වගේ චූටි gap එකක්. A very small gap, and draw the straight line. This is y equals to minus x. Here, I don't know whether it's visible for online students. Yeah, it's visible. Here, cute gap, not a big gap, very small gap. Very small gap. It's visible slightly for the reader. That's enough. Godak me wage loku gap එකක් තිබ්බොත් වැරදි. Right? A small gap. Why we keep the small gap? 0 is not accepted for that. 0 එක මෙයාට accepted නැහැ. That's why you keep a small gap. These things can't give it as a note to write. ඒව මතක තියෙන්න ඕන දේවල්. Okay. Now පුතා, after this point, ඔයාලට මං හිතන්නේ graph 15ක් 20ක් විතර අඳින්න දිනවද? Right, do the first one, and under the same one I have given space. Example number 2. Example number 2. Define and plot the graph of the function y equals to modulus of x plus 1. Make කරන්නකෝ බලන්න. Y equals to modulus of x plus 1. Do it. Quickly do it. මේක නම් හිමින් කරන්න වෙලා නැහැ. Make it quick. Quickly finish it. I'll give you a couple of minutes. And students, drop a message in the chat box. All good? Understood? Any unclear part? I need individual responses quickly. I need individual responses. Okay, finish this. Finish this. Okay, right. I'll do that graph. Do not use pens. වැරදිලාවත් pen use කරන්න එපා. Right. So y equals to modulus of x plus 1 here, see. Y equals to modulus of x plus 1. Listen carefully. How do we define this? If this function is positive or positive or equals to 0, greater than or equals to 0, it will return the same function. If this function is negative, it will return minus times the function. Now we'll have to simplify the inequality. Then previously there is nothing to simplify, but make case we'll have to simplify the inequality. Y equals to modulus of x plus 1 equals to x plus 1, where x is greater than or equals to minus 1, no? Minus x minus 1, where x is less than minus 1. So the margin is minus 1. So we have two functions. What are the two functions? Y equals to x plus 1 for x is greater than or equals to minus 1 region, and then y equals to minus x minus 1 for x is less than minus 1 region. For x is less than minus 1 region. So for these, you have to find the coordinates now. Margin is minus 1, start from minus 1. When x equals to minus 1, we get y equals to 0. Ne? Greater than equals to minus 1, then x equals to 0, y is equals to plus 1. Then x equals to 1 will give you y equals to 2. Right. Since even though the margin is not included, better to start with the margin because it's easy to plot the graph. X equals to minus 1, y is equals to 0. When x equals to minus 2, because less than minus 1 region, then take values less than minus 1. When x equals to minus 2, minus to minus plus, plus 2 minus 1, y is equals to 1. When x equals to minus 3, y is equals to plus 3 minus 1 plus 2. We get coordinates like this. Then hang in. This is y-axis, x-axis, origin. Minus 1 is the margin, minus 1, and then 0 plus 1. For this, minus 1, minus 2, minus 3, and minus 2, minus 3 minus 2, minus 3. Now here say, when x equals to minus 1, y equals to 0, we have one coordinate. When x equals to 0, y equals to 1, we have another coordinate. When x equals to 1, y equals to 2. Same gap, 2. We have another coordinate here. So I'm using my free hand and eye balance to draw this method minus 1 gap ready. I'm taking eye balance, you measure and take them. This is y equals to x plus 1 graph. Greater than or equals to minus 1 region. That is accepted for greater than equals to minus 1 region. Yeah. When x equals to minus 1, y equals to 0, but it is not accepted. When x equals to minus 2, y equals to plus 1. And then when x equals to minus 3, y equals to plus 2. Right. Since this one is not accepted, equal sign is not there. So this value is not accepted. Keep a small gap and draw this. This is y equals to minus x minus 1 graph. Right. Then take I haven't included any exercises from this graph plotting part. So I will give you some exercises, do them. Exercise, write these questions. First of all, write down the questions. Define and plot the following graphs. Define and plot the following graphs. Define and plot the graphs of following functions. Graphs of the following functions. Right. Question number 1. Y equals to y equals to fx equals to, I'll just give it as y equals to modulus of x minus 1. Second one, y equals to 2 times modulus of 2x plus 1. Third one, y equals to 3 times modulus of x plus 5. Fourth one, y equals to minus 2 times modulus of x minus 2, x plus 2 plus 3. Fifth one, y equals to past papers for the number. Right. කොහොමද ගන්නේ? තව එකක් ගමු. Y equals to x plus 1 plus x minus 2. Sixth one, y equals to modulus of x plus 1 y equals to modulus of x plus 1 modulus of it. Okay, double modulus තියෙන්නේ. Okay, these two questions are important. Right, දෙන්න පුළුවන් ඔක්කොම graph types are given, and then solving equations using modulus functions, and ඒක කරලා තමයි solving inequalities using modulus functions part we can do. අද වෙලාව ඇති වෙයිද දන්නේ නැහැ, we'll see. In case if the time is not enough, next week morning partial fractions වලට කලින් I'll be finishing the modulus inequalities, because to plot the graph චුටි වෙලාවක් යනවනේ. Right, do it. There are 6 questions. I'll give you 10 to 15 minutes. Give it a try. පරිස්සමෙන් කරන්න. Do this one separately. වෙනම කරන්න. I'll give it 10 more minutes. Quickly do it. I'll give you 5 more minutes, and then when I'm discussing, you have to do with me, yeah? Right. Right. Okay. Now listen. if your answer is correct, you can correct with me, or else if your answers are wrong, you can write down my answers. Mage ekate cross check karaganna. Y equals to modulus of x minus 1. We know that. How do you define it? We will get the say here when the function is the modulus එක ඇතුලින් එක්කන විතරයි, the one that is inside the modulus only we define here. Okay, when x is greater than here, when the function is greater than or equals to 0, it returns the same value. If the function is negative, it returns what? Minus times the function. It returns the minus times the function. Whether y modulus of x minus 1 is equals to, right? So I will take this one as here, this is x minus 1, x is greater than or equals to 1, this is minus x plus 1, x is less than 1. So the margin is 1. So we have two functions primarily where y equals to x minus 1 for the region x is greater than or equals to 1, y equals to minus x plus 1 where x is less than 1. Listen carefully, okay? Then margin is 1, so we can start with the marginal value. When x equals to 1, y equals to 0, right? When x equals to greater than or equals to 1, so 2, y is equals to 1. When x equals to 3, y is equals to 3 minus 1 equals to 2. 2. Metana. When x equals to minus 1, minus into minus plus. So when x equals to 1, minus 1 plus 1 equals to 0. When x equals to 1, y equals to 0. Less than 1 means I can consider x equals to 0. When x equals to 0, y equals to 1. When x equals to minus 1, y is equals to minus into minus plus 1 plus 1 plus 2. Right. So I will plot the graph of this function here. X, y, origin, right? And then we have when x equals to 0, 1, same gap again, okay? Otherwise you won't get straight lines. Take the same gap, measure and take the same gap. I'll take with the I balance. X equals to 0, minus 1, minus 2. So from positive side, plus 1, plus 2, plus 3, plus 1, plus 2, plus 3, and then 0, 1, 2. Right. When x equals to 1, y is equals to 0. When x equals to 2, y is equals to 1. When x equals to 3, y is equals to 2. When x equals to 3, y is equals to 2. Right. So we get a straight line like this. You take properly as a measurement. Y equals to x minus 1. Where x is greater than or equals to plus 1 region only, that's valid. This part, when x equals to 1, y equals to 0. When x equals to 1, y equals to 0, 1. Point. When x equals to 0, y equals to 1. Here we have another point. When x equals to minus 1, y equals to 2. Here we have another point. Right. So here, this is y equals to minus x plus 1 graph. Okay. So this is first question. Second one. Right. I'll have to erase the board because I need the questions there. Okay. I'll erase the top part of the questions. Right. When y equals to 2 times 2x plus 1. Second question, y equals to 2 times modulus of 2x plus 1. Right. So we'll define that one. Y equals to 2 times modulus of 2x plus 1. How do we define it? Now most students make this mistake. What is it? They write 2 times 2x plus 1 is greater than or equals to 0 kila liyana. Varadi. Why is that? Modulus is only for this function, no? Then when we are defining only for that part. 2x plus 1 is greater than or equals to 0. If this modulus part is greater than or equals to 0, that modulus part is positive. If that 2x plus 1 is negative, then 2 times minus 2x plus 1. We are defining only the modulus part, okay? Not the entire thing. Not the entire thing. Now, y equals to 2 times modulus of 2x plus 1 is equals to, we get 4x plus 2, here minus 4x minus 2. Solve for x, x is greater than or equals to minus half, x is less than minus half. So half is our margin, right? So I need to keep the questions here. Shall I erase this graph? Previous one, shall I erase it? Online students, throw a message in chat box. And here, Buddha, see, I am keeping a gap here because x is less than one region we have taken. X is less than one region. Okay. Right. So equal sign is not there. That's why I kept a gap here. Right. I'm erasing the board. Shall I erase the board? You guys? Magana darga. Right. X-axis. Before that, need to find the coordinates, no? So we have primarily two functions. Y equals to 4x plus 2, where x is greater than or equals to minus half region. And we have another one, y is equals to minus 4x minus 2, where x is less than minus half region. Harine. Now, here's a yeah. When x is equals to minus half, y is equals to 0. I'll start from the margin. When x equals to minus half, 4 times half is 2, minus half from minus 2. Minus 2 plus 2 is 0. Greater than or equals to minus half means the other one is going to be 0. 0. When x equals to 0, y is equals to 2. Right? When x is equals to 1, y is equals to 4 times 1 is equals to 4. 4 plus 2 is equals to 6. Or no, wait, no. How about this? When x equals to minus half, this is going to be still y equals to 0. Less than minus half means x equals to minus 1 we can take. When x equals to minus 1, y is equals to minus into minus plus 4 minus 2 is 2. When x equals to minus 2, you get y is equals to plus 6. Right? Plus 6. So we get not always symmetrically you get examples coincidentally symmetric. Not always you're going to get symmetric distributions, okay? You get different functions also. These questions I gave you by thinking, no. Past papers different types of functions are also there, okay? Not always modulus function is symmetric on both sides. Not always symmetric. Gradient we get different ones. Right. So when x equals to 1, I will take somewhere here because we have to mark, 1, yeah, 1 I will take like this, 2 I will take like this, minus 1 I will take like this, minus 2 I will take like this. Why I am taking a greater dispersion? Because we have to mark minus half also in between 0 and minus 1. When x equals to minus half, y equals to 0. When x equals to 0, y equals to 2. Methana, you don't have to take the same scale as x-axis on the y-axis. Huh? No need to take the same scale as the x-axis on the y-axis. When x equals to 1, y is equals to 6. 3, 4, 5, 6. So we get like this. So this is y equals to, good practice is that, and the graphic name what part of the graph you plotted. This is y equals to 4x plus 2. Name that. And below minus half, when x equals to minus half, it's 0. When x equals to minus 1, y is equals to 2. When x equals to minus 2, y is equals to plus 6. Here we don't have the equal sign, so x is not equals to half. Not equals to half means not, y is not equals to 0. So we have to keep a small gap and plot this. Keep a small gap and plot this. Okay, so those are straight lines. This y equals to minus 4x minus 2. You don't use your free hand to draw this one. Now ruler ekak tila andinda. These are not curves, no. These are not anit curves, no. Straight lines are still may consider that curves, but make our karakana curves, right? All together, if you take, that's what we call this complete modulus function. Make complete eka me denna ekatu korot. Both of them together, y equals to 2 times modulus of 2x plus 1. Both of them together, it's that, right? That has two parts. That's a piecewise function. There are two pieces, right? Hare. දැන් කවුරු ලයිව් එකේ හිටියත් නැතත් මට අදාළ නැහැ. අද කරන්න ඕන වැඩ ටික මම කරනවා. රෙකෝඩින් ඉල්ලුවාට දෙන්නේ නැහැ. If it is a valid reason, no problem. I'll give. යහෝ එක තැන ඉන්න බෑ කියලා කියන්නේ පැය 6ක් 7ක් තීරුමක් නැහැ. Exam you have to somehow keep your butt in one place and write the paper for 3 hours. Huh? පස්ස පැත්ත එක තැනක තියන් ඉන්න බැර නම් කේස් නේ බා. Then you will have to take a medicine. තුවාලයක්වත් දන්නේ නැහැ නේ එක තැන ඉන්න බැරි. බනිද්දී එකක් ආවා. බලපන්. From the paid class students. Sir, in the second, we'll get us more space. In the second, will it get us more space? Yeah, no, because we don't have an equal sign, right? In the second one, right? From the paid class students, right? Right? They don't understand the benefit of covering the syllabus early. Ask the 25 A-level batch, they will tell. Maths කලින් cover කරගත්තොත් කොච්චර benefit ද කියලා, because last moment physics එක නන්නත්තර වෙනවා. ඒක එහෙම තමයි. Because of physics, you don't have time to look after chemistry or maths in the last moment. Because of physics. හේතුව ගොඩක් lectures ලා අන්තිමනේ cover කරන්නේ. ගොඩක් lectures ලා, not everyone. Right. Physics වල හරිනම්, now when did you start mechanics? Now what's the lesson you all are doing in mechanics? What's your class? Where are you going for? Yeah. Tension. The main topic is Newton's law. Yeah. Newton's law of friction. Start panel. How about the practicals in that one, previous lesson? What about the others? All of you listen carefully. Karuna Karala, physics practicals hariyatama karaganna, because physics practicals, now you know, physics paper 50 marks is from MCQ. The balance 50 marks is coming from the essay paper. Essay paper in 25%, I can't remember how many percent is essay paper, how many marks allocated for the structured essay. Structured essay, there are 4 questions, no? From 4 practicals. Out of 38 practicals, you get 4 practicals. Actually, there were 42 practicals. Practicals hatarak ayin karala thiyena syllabus එකෙන්. The 4 practicals that is related to mercury. Physics practicals hatarak ayin karala thiyena. Okay, that quill tube එකෙන් කරන practical එකයි තව මේ කොහොම හරි mercury related 4 practicals has been removed from your physics syllabus. Syllabus එකෙන් update එකේ ඉන්න, right? So in your first lesson, which is measuring instruments, I mean units and dimensions, last part measuring instruments. Measuring instruments park thina. What are those 5? Vernier caliper එක ඉගෙන ගත්තේ vernier caliper විතරක් දන්නවා. Meter rule, vernier caliper, micrometer screw gauge, sperometer, travelling microscope. මම ඉගෙන ගත්තේ අවුරුදු 8ක් විතර වෙනවා. ඔබ දැන් ඒ ලෙවල් අවුරුදු 8ක්ද 7ක්ද මට මතකත් නැහැ. Yeah, 8ක් විතර වෙනවා. Right? උඹලට වඩා මට මතකයි. Because I didn't do මේ මොකක්ද අර මේ අපිට recording තිබ්බේ නැහැනේ. We didn't have recordings. පන්ති ගියොත් that day you study, if you didn't go to the class, no recordings. කොරෝනා නෙවෙයිනේ අපි දවස්වල. last final year ලඟ වෙද්දි කොරෝනා එතකොට තමයි පැතිරෙන්නේ ගත්තේ. 2020 is the lockdown, right? So අපි ඉල කරන දවස්වල කොරෝනා නැහැ. The first 2 years no corona, right? එතකොට we had to do it everything on our own. So somehow you had to do no recordings. So recordings නැති හින්දා within the class time somehow we had to complete the work. So can remember everything. You all are not like that. Sir is doing a free session, no? So ඒ හින්දා මේ recording sir දායි. That's why when everyone is doing the paper classes for free for 27 batch, I'm not doing the paper class for free. Paper class free කරන්නේ. I thought of doing it for free because you guys disappointed me by not joining the coordinates geometry sessions properly. ඊට පස්සේ තේරුම් ගත්තා giving something for free doesn't add a value. You guys don't value it and you guys don't complete the work. I'm doing the free sessions and putting those sessions, covering up the lessons early. The last moment I know that you can't do it. Now circles and straight lines means put a grade 13 first term and grade 13 second term. Next month statistics I am doing. Statistics කියලා කියන්නේ grade 13 second term and grade 13 third term. Statistics and probability. කරගන්න ඇවිල්ලා. කරේ නැත්නම් ඉතින් මට මොකුත් කියන්න බෑ. It's not a free one, it's a paid one. Okay, it's a paid seminar. But I recommend the 2027 A-level batch students to come and join. If you all are joining, I will give a greater discount for that one. Sometimes බලමු ඒ දවසකින් දෙකකින් වගේ you will get the updates about this one. Right? It's happening online. Online only, yeah? Online. ඒක කරගත්තොත් 150 marks in short questions, essay questions and 50 marks in short questions. 200 marks in applied paper out of 1300. Essay hatama gattut. Right? Covering up this one early again, then applied maths we have to do only few lessons. Now I will be podi lessons like this in seminars for the 4 days we can cover it up like impulse and momentum, work, energy, power, ඊළඟට ඔය මේ තියෙන podi lessons like projectiles. Those lessons can be done in the seminar sessions. Mathematical induction with pure maths, binomial theorem. Those are small lessons like this. This is small කියලා කිව්වට මේ it takes time to plot the graphs, right? But the other lessons, there is nothing to plot graphs. So I am finishing them early. So it will save small lessons all together. Pure maths, applied maths, small lessons together. 3 months, 4 months. Nearly 3 months. If we can do it in an extra session like this through seminars, seminar it's a regular class no actually for you guys. I'm not doing a much of a promotion for these free seminars no. Just a post link free share post share. I'm just sharing the link up as an open one in the groups. That's it. Aranikang Facebook boosting dala make a heavy promotion ekak. The reason is my main goal is my paid class, my regular theory class students. Others I know ek mata added advantage also for them. Right? But you have to understand I'm doing this for you. Value ekak ganne nathi ko alagati. So coordinates geometry regularly in a set inna, and those guys are working really good. So focusing on them, I am covering up the coordinates geometry this month. This Sunday with the coordinates geometry fully right. And then the next month, first week we are starting statistics. Statistics online it's a 5-day seminar session. Okay, 3 days in December. Last week of December is a holiday week. None of my classes will be conducted. January 2 weeks. First 2 weeks I'll be taking statistics. It's an additional session apart from the regular classes. Regular classes will happen as usual for Saturday online, Sunday hybrid, and Monday physical. Okay, so in that session we'll be covering up trigonometry finish karla. We'll be finishing off vectors also. So you have to cover the syllabus early. Covering the math syllabus early is a greater benefit. Because last moment physics physics 38 practicals are there. Out of 38 practicals, only 4 practicals are coming. What kind of 4 practicals you don't know what kind of 4 practicals will be there. There's a tendency, or there's a weight for lessons. Generally, if we take 4 questions are 4 practicals are selected out of 38 practicals. Make a maths permutation and combinations lesson 38C4. If you simplify this, you will get the number of combinations that they can select the questions. What does simplify? 38C4 means 38 factorial. If you don't know the factorial idea yet, if you know Hondai, divided by 4 factorial, 38 minus 4, 32 factorial. Factorial if it is 3 factorial, 3 factorial means from 3 until 1 all the integers multiplication. 3 times 2 times 1, or is 1 times 2 times 3. Again, 38 factorial means 38 times, 37 times, 36 times, 35 times until you get to 1. එතකොට දැන් මෙතන simplify when මෙතන until 32, 1 to 32 we can simplify. So we get 33, 34, 35, 36, 37, 38 divided by 4 factorial 1 times, 2 times, 3 times 4. Simplify කරලා බලන්න answer කීයද කියලා. එකන් ආතල් එකටත් එක. I'll use the calculator. Right, ඔයාලා පස්සේ simplify කරගන්න. Just to give an idea, හරි. කොච්චර ලොකු වැඩ ගොඩක් ඔයාලට physics වල කරන්න තියෙනවද කියලා කියන්නේ. 33, 34, 35, 36, 37, 38 divided by 1, 2 times 3 is 6, 6 times 4 is 24. මෙන්න මෙච්චරක්. 82820 ඒ කියන්නේ paper එක හදන එකට out of 38 practicals ඌට කැමති practicals 4ක් තෝරගන්න මෙච්චර possibilities තියෙනවා. He has plenty of choices, right? 8,2,820,430 possibilities, combinations. ඒ කියන්නේ one practical from මොකද්ද මේක ඇතුලේ මෙහෙම තියෙන්නේ like 4 practicals, all the 4 practicals from measuring instruments. වෙන්නේ නැති ඒවා හරි. So all the possibilities are there. The මෙතනින් කපලා කොටලා වෙන්න බැරි situations ඔක්කොම අයින් කරා somewhere around 3 billion possibilities වගේ තියෙනවා. right? Then hitapanko. Obviously, this question obviously will come to the exam. You have to remember all 38 practicals. This atama mataka තියෙන්න ඕන. මොකෙන්ද දන්නේ? No bang. All the 38 practicals in physics. Measurements la තියෙන measuring instrument තියෙන්නේ පහයිනේ ඔය. Right? So understand the complexity in this one. So you have to remember all 38 practicals. එකක්වත් අමතක වෙන්න බෑ. ඔක්කොම පුළුවන් වෙලා යන්න ඕන. Whatever the four they give you, you should be able to write. But obviously one practical is from mechanics and one practical is from optics. ඒක දන්නවා. Right, අනිත් දෙක තමයි මාරුනේ. අනිත් දෙකේනොත් එකක් most probably from this one. What is it? 10th lesson. මේ mechanical properties of matter. Probably වෙනස් වෙන්න පුළුවන්. I'm 6 lecturer no. මම දන්න දේවල් වල මම කියන්නේ. මමත් physics කරානේ. Right? So මතක තියා. That's why I'm saying ඔක්කොම පුළුවන් වෙන්න බෑ. 38 practicals හොඳටම පුළුවන් වෙන්න ඕන. And then mechanics වතුර වගේ පුළුවන් වෙන්න ඕන because otherwise you can't understand the other lessons. Other lessons are depending on mechanics. Right? So let's say you didn't do mechanics properly, then the other ones backlog. The other it was a thermal physics backlog. When it comes to gravitational fields, there is not much of mechanics needed. Mechanics ඕනේ. අර මේ formulas the F equals to ma එක දාන්න වගේ mechanics ඕනේ. Right? Otherwise other fields are complex. Electrostatics field, magnetic fields on no amaru. Right? And then electronics tawa amaru. Physics amaru, yeah. You are still doing what? Mechanics. Some classes tama mechanics measuring instruments what ivarane. Right? Mechanics how many practicals? Mechanics lesson 7 practicals. Oscillation and waves 12 practicals. එතකොට මේ oscillation and waves lesson එක මාස 4ක් මාස 2ක් 3ක් අදිනවා. practicals එක ගත්තොත් තව වැඩි. ඔබලා කවදාද physics syllabus cover කරන්න යන්නේ? Practical in the தெரியாவா? Very good. Explain him later. What is a practical in physics? නෑ තාම practicals වලට කරලා නැහැ in mechanics. Mechanics වල practicals තාම නෙවෙයි වලට. Mechanics වල you will get mechanics practicals you will get in fluid dynamics, hydrostatics අනේ වල practicals තියෙනවා. Rotational motion වල මේ Newton law වල මේ practicals නෑ ළමයි. Right? So 27 A level, please understand covering up syllabus in mathematics early. උඹලා මට පස්සේ thanks කරයි. මේක ඉවර කරලා දෙනවට. Right? එක එක්ක මම නිකන් ගණන් හදලා පෙන්නනවා by the end of December 41% of the people. 41%, no? By the end of December, if you have completed the syllabus with me properly, while selections questions, if you are selecting the questions and doing, nearly 41% of the paper you can complete. S එක December වෙද්දි තියෙන ඔයාලට pure වලින් විතරක් ගොඩක්ම contribution එක. Right? Right? So understand and do it. I take longer hours because I don't want to increase the speed of the discussion. Discussion speed එක increase කරා නම් within 3 hours I can do the same thing. එහෙම කරලා හරියන්නේ නැහැ. I have to give you time to try the questions within the class time. Questions දීලා ඕක explain කරලා වැඩ කරන්න නැති වෙලා යනවා. So that's why I take long hours. Right? Okay, this question. When we define this one, yes, yeah, modulus is for the x. When x is greater than equals to 0, it will return the positive x, but the function is 3 times plus x plus 5. When x is less than 0, 3 times minus x plus 5. X is the one that we are defining, not the everything. 3 times minus x plus 5. So this one will give you y equals to 3 modulus of x plus 5, right? 3x plus 5 minus 3x plus 5. So x is greater than or equals to 0, x is less than 0, right? We are defining only for the x, no? Then we have two functions, y equals to 3x plus 5 for x is greater than or equals to 0. Then y equals to minus 3x plus 5 for x is less than 0. Right? So we'll start with the margin. When x equals to 0, y is equals to 5. When x equals to 1, y is equals to 8. Right? When x equals to 2, 2 එකක් ඕනේ නැහැ නම මට මේ 8 වෙනකම් මාක් කරගෙන ලොකු අමාරුවක්. If you want, you can do x equals to 2, 3 times 2 is equals to 6, 11 kilo now. Then x equals to 2, y equals to 11, but until 11 I'm not going to draw, okay? When x equals to 0, y is equals to 5. When x equals to minus 1, y is equals to plus 8. When x equals to minus 2, minus 2 minus 3 plus 6 plus 5, y equals to 11. So we get x-axis අපිට පල්ලයට ගන්න y-axis origin, right? Plus 1 plus 2 minus 1 minus 2. When x equals to 0, y equals to 5. 1, 2, 3, 4, 5. When x equals to 0, y equals to 5. When x equals to 1, y equals to 8. 6, 7, 8. Right? So it goes like this. 11 y equals to 3x plus 5. 3x plus 5. Obviously, because intercept is 5, no, in a 5 will intercept and do. Right. When x equals to 0, y equals to 5. When x equals to minus 1, y is equals to plus 8. When x equals to minus 2, y equals to plus 11. 11 mark run, I don't have enough space. So this is the other graph. This is y equals to minus 3x plus 5. Minus 3x plus 5. හරනේ ඔන්න ඔහොම. We'll do the next one, fourth one. Right. No, I asked because after your session until 3:30, no. So I will quickly go home and come. So you stay in the session, I'll give the key to you and go. Right. Next one. Y equals to fourth one, y equals to minus 2 times x plus 2 plus 3. So here, let's define this. Modulus part is the only one that we have to define. So x plus 2, if this is positive or equals greater than or equals to 0, it will be minus 2 times plus x plus 2 plus 3. If this is less than 0, minus 2 times minus x plus 2 plus 3. So we get y equals to minus 2 times modulus x plus 2 plus 3, where we get minus 2x, minus 2 into minus plus 2 equals to minus 4, minus 4 plus 3 is equals to minus 1. Minus into minus x is minus into minus plus 2 times x 2x, minus into minus plus 2 times 2 is 4. 4 plus 3 is 7. So we get x is greater than or equals to minus 2, x is less than minus 2. X is less than minus 2. Right? Now, we have two functions y equals to minus 2x minus 1 for x is greater than or equals to minus 2 region, y equals to 2x plus 7 where x is less than minus 2 region. Right? Modulus functions වල තව ගොඩක් කරන්න තියෙනවා. Listen, I still giving you the training to plot the graphs of modulus functions. ඊට පස්සේ solving equations using modulus functions. ඒකේ example දෙක තුනක් විතරක් කරොත් ඇති, because when it comes to inequality also we are going to do the same thing. ඒකත් එක්ක modulus functions done. So sometimes to discuss the past papers we might not have enough time. So if so, then next week we have another seminar session for partial fractions and logarithms. I'll be taking the past paper discussion from modulus functions first, and then I'll be starting the partial fractions. We'll see if I don't get enough time to do the partial fractions. Instead of partial fractions, I'll be doing logarithms next week. Logarithms karla partial fraction next month poe day ge karo. Okay. We'll see. Right. So when x equals to minus 2, start from the margin, it's easy. Minus in here, see, when x equals to minus 2, minus into minus equals to plus 2 times 2 is 4, 4 minus 1 is equals to 3, y is equals to 3. When x equals to greater than equals to minus 2, minus 1, this gives you plus 2, minus 1 is equals to plus 1, y is equals to 1. When x is equals to 0, y is equals to minus 1. Mu palle hata yane ekek ne, negative මේකක් නේ. Right. Where x is equals to minus 2, y is equals to 3. When x is equals to less than minus 3 and minus 3, we get y is equals to minus 3 plus minus 6 plus plus 1 plus 1. When x is equals to minus 4, we get y is equals to minus 8 plus 7 minus 8 plus sorry, the simplification 2 times minus 6 is plus 1, make a minus 1, minus 8 plus 1 minus 1. Right. I'll erase this. origin. Right. When x equals to -2, -1, 0, then -1, -2, it was a -2, -3, -4. I can negative side, I need more space, no? Not on the positive side. X axis positive side wala 1 විතරක් වෙනකන් නිකන් ගත්තොත් ඇති, because negative side is the area where I need more coordinates. -3, -4, -5. Right? So you can do these adjustments if you do it with a pencil. Pen එකෙන් කරා නම් ඉතින් ඉවරයි. ආය මකමක ඉන්න වෙනවා. When x equals to -2, y is equals to -3, sorry, +3, +1, +2, +3. When x equals to -2, y is equals to -3. Here we have a coordinate. When x equals to -1, y is equals to 1. This is 1. When x equals to 0, y is equals to -1. Then goes like this. This is y equals to -2x -1. X is greater than equals to -2 region means this region. May pattern hurry. That's correct. Now the next part. When x equals to -2, y is equals to -3. When x equals to -3, y is equals to 1. Then when x equals to -4, y is equals to -1. Y equals to 2x plus 7. 2x plus 7. Both of them together, if we take, that's what we call how the mod 2 times module -2 times modulus of x plus 2 plus 3. Right. Yeah, hurry. Next one is important, so everyone should stop working and listen. Next one kai last one එක පට්ට වැදගත්. Past papers වල this one is evaluated in past papers. Make ළඟකදී in the near future you can't see a past paper question came from this, but from this ඇවිල්ලා තියෙනවා 2022 or something, I can't remember. Wait. Yeah, 2022. In 2022, මෙන්න මේ idea එකෙන් there was a question. Right. So before I do that, first of all, finish this. Then I'll erase the board. Okay. Until that, online students, drop a message in the chat box. Until this point, so far, whatever we discussed, all good, understood? Clear with that? I need individual responses. Drop a message in the chat box. Resta. Okay. Right. Shall I erase the board? When you drink water only, I realize that I have to drink water. I don't even drink 500 milliliters a day. Not good for your kidney. Students, karuna karala during the class, every time, please drink some water after every 30 minutes. Now, since this is easy physical class, students, let me washroom and now away. No problem, go and come. Okay. වතුර බොන්න නැතුව වැඩ කරන්න එපා, හොඳ නෑ. උඹලට කොහොමත් හොඳ නෑ, මටත් හොඳ නෑ. ඒක different story. All right. Now I'm going to erase the board. Okay, there's a question or there is a chat in the chat box. All good. Okay. Sharfa, please send the message to that everyone device. Okay. Sorry, I mean everyone chat. Right. Now listen, this question is very important. Listen, y equals to modulus of x plus 1 plus modulus of x minus 2. I will take it like this. Fifth question, make a fx kilogram. I'll just name this function as fx. Can you see it's a sum of two functions, no? It's a sum of two functions. Then with the sum of two functions, you see, I can consider this as one function and define it separately. Take this one as another function and define it separately, because basically the fx function is gx plus wx. So I will take gx function separately, which is modulus of x plus 1. Let's define that. You see, modulus is for the x plus 1. When x plus 1 is greater than or equals to 0, you get positive x plus 1. When x plus 1 is less than 0, you get minus times x plus 1, which is minus x minus 1. So if we define it further, gx is equals to modulus of x plus 1, x plus 1 where x is greater than or equals to minus 1, minus x minus 1 where x is less than minus 1. Right? Same as that, let's try to define wx. What is wx? Modulus of x minus 2. Define them. When x minus 2 is greater than or equals to 0, we get positive x minus 2. When x minus 2 is less than 0, we get minus times x minus 2, which is minus x plus 2. Let's define it further. Wx, modulus of x minus 2, this is going to be x minus 2, x is greater than or equals to 2, minus x plus 2, x is less than 2. Now I can see this is gx, this is wx. Then what I can do, here gx and wx, if I am adding them, then I'll have to think of common ones, acceptable ones. Now here see, when I'm adding, if I'm taking fx equals to gx plus wx. And then if I'm considering gx plus wx, we have multiple pieces. No, not all 4 pieces are going to come. Why is that? X plus 1, and if I'm adding x minus 2, here x plus 1, x minus 2. You have to check x plus 1 plus x minus 2. X plus 1 plus x minus x plus 2. Check this one and this one. This one and this one. You have to add everyone. And check with the inequality. Acceptable ones stick with it. Then you have a rough work. Then before we move to that part, we have a small rough work. Rough work. What is the rough work? Now if I'm adding these two, x plus 1 plus x minus 2. You see, x plus 1 plus x minus 2 gives you 2x minus 1. If I'm adding these two, here see, I will take 1, 2, 3, 4 kilogram for the reference. Then it's easy for us to understand. No? 1 plus 3, then add colors. We get, because we have to add gx and wx, we get 2x minus 1. 2x minus 1. Right? Again, gx plus wx, one function is 2x minus 1. How about this one's defined region? Region is this says x is greater than or equals to minus 1. This says x is greater than or equals to 2. Take the number line. One says x is greater than or equals to minus 1. The other says x is greater than or equals to 2. Then finally accept right? Because this a greater than or equals to 2 is valid for both of them. Greater than or equals to minus 1 valid only for this part. When both are set together, the greater domain is the one coming. Greater domain you have to check with that analysis. Right? x plus 1 is greater than or equals to minus 1, the other one is greater than or equals to plus 2. If I plot them, I can see both of them are valid for what region? X is greater than or equals to 2. We are getting a valid inequality now that is possible to consider. Then 2x minus 1 where x is greater than or equals to 2. Next, 1 plus 4. First one and fourth one. Add and see. Plus x. Here x plus 1 minus x plus 2. X plus 1 minus x plus 2 plus x minus x 0. Plus 1 plus 2 plus 3. We just get 3, which is y equals to 3. Straight line. Let's check about the inequality. X is greater than or equals to minus 1. Here, see. X is greater than or equals to minus 1. The other one is x is less than 2. Less than 2. Less than 2. Then what's the region for this? Acceptable region. Valid region. This is valid for x is greater than or equals to minus 1, less than 2 region. This is valid for x is greater than or equals to minus 1, less than 2 region. Right? Now let's check 2 and 3. 2 plus 3. Let's check 2 plus 3. What is 2? Minus x minus 1. 3 is plus x minus 2. Minus x plus 2 cancelling out. Right? Minus 1 minus 2 minus 3 venama. How about the inequality? This one says x is less than minus 1. Minus 1 ekata palleha. This one says x is greater than or equals to plus 2. May pathi. There is no any common region for both of them. Then not a common region. Then this one is not considered. Make a consider 3 less than 2. 2 plus 3. Mundinnage sum making in a function not coming. It's not valid. Right? So how about the other one? 2 plus 4. Minus x is minus 2x. Minus 1 plus 2 is plus 1. So minus 2x plus 1. This gives you minus 2x plus 1. How about the region? This is not coming. Regions for your betterment of understanding. So I'll write how to identify the region of this. Greater than or equals to minus 1. Greater than or equals to plus 2. This is the accepted region. That's why this is valid. How about this? Greater than minus 1. Less than or equals to 2. Sorry. Greater than 1 and 4. No? 1 and 4. This is greater than or equals to minus 1. Less than 2. Again, this region only. Right? This region only. They make it mama accepted region this region only. If you want, you can write down a note on your own. But if you take 2 and 3, if we take 2 and 3, we get minus 3 when you add the functions. Inequalities are less than minus 1, greater than or equals to plus 2. Greater than or equals to plus 2. Two different regions. No common region, so make a ganna bad. How about 2 and 4? 2 and 4 when you add them. 2 and 4 when you add them, minus 2x plus 1. Minus 2x plus 1. If you draw the inequality, x is less than minus 1, less than minus 1. Metana, x is less than plus 2. Make a plus 2. X is less than plus 2. Then not common wenne this region, no? This one is valid for x is less than minus 1 region. Minus 2x plus 1 where x is less than minus 1. Three functions are there. Mutamape fx. This is our y equals to fx equals. These are y equals to fx equals to modulus of x plus 1 plus modulus of x minus 2. Onna menna me කැලි තුන. These are the defined domains. Right. Clearly write it down before I plot the graph. If you want anything to write down as a special note, ලියා ගන්න ටක් ගාලා special note එකක් විදියට. When you come across these kind of two modulus functions in the same graph, then you will have to separately define them and take the pieces and check the valid inequalities or as valid ranges, acceptable ranges. No common range. So no common range means no valid region for the final one. Common range so we get a different graph. Do you have time to go home and come? Sure. 1.5 now. 2 to 3:30. Where do you live? You can go take a nap and come. Right. Shall I erase the board? Shall I erase the board this side? Online students? Okay. Shall I erase this side? Okay. Right. Now, I'll erase this part. Here, see. We have first one is y equals to 2x minus 1, valid for the region x is greater than or equals to 2. And we have another one, y equals to 3, valid for the region minus 1, x is greater than or equals to minus 1, less than 2. Right? And we have another region, y is equals to 2 minus 2x plus 1, valid for the region x is less than minus 1. This one actually we don't have to find coordinates no more, just a straight line. No? Y equals to 3 is a straight line that goes through 0, 3 point parallel to the x-axis. No, in coordinates geometry we studied that. How about this? When x equals to 2, we get y equals to 3. No, margin again pattern. When x equals to 2, 2 times 2 is 4, 4 minus 1 is 3. Greater than or equals to 2 hinda when x equals to 3, y is equals to when x equals to 3, 2 times 3 is 6, 6 minus 1 is 5. Right? 2 coordinates is enough. Make a straight line. Let's check about this. When x equals to minus 1, y is equals to minus into minus plus, plus 3. Let us say when x is equals to minus 2, okay, when x is equals to minus 2, we get y is equals to minus into minus plus, plus 4 plus 1 plus 5. On no now. And now we can plot. Be very conscious about the ranges and the equalities. Okkom balanda. X-axis, y-axis origin, plus 1, plus 2, minus 1, minus 2. Let's take this. When x equals to 2, y is equals to 3. Plus 1, plus 2, plus 3. 1, 2, 3. When x equals to 2, y is equals to 3. When x is equals to 3, y is equals to 5. 4, 5. So, greater than, here this is valid for greater than equals to 2 region, greater than equals to 2 region, may path this region. This is y equals to 2x minus 1. Then y equals to 3. Y equals to 3 is between, here see, between minus 1 and 2, but minus 1 is included, 2 is not included. Why? Equal sign is not there. No? Here there's a small gap. Why? Equal sign is not there, so I can't touch. How about the other one? Less than minus 1. When x is equals to minus 1, y is equals to 3. When x equals to minus 2, y is equals to 5. Less than minus 1. So, method touch goes like this. This is y equals to minus 2x plus 1. So, we have all together may set our y equals to modulus of x plus 1 plus modulus of x minus 2 mundenna. Mun set mundennage ekatuwa tama meka. All of them together. All of them together. Then make mehema දාන්න එපා හෙන කැතයි. Okay. This is our complete graph. All of them together. All of them together. So this is y equals to 3 graph. On. So we get different graphs like this. Samahara වෙනවා මෙන්න මෙහෙම. You will get some graphs like this. There are instances, right? We'll do the next one also. අනිත් එකත් කරලා ඊට පස්සේ යන් solving modulus equations. Where did you take your breakfast? budget angadi waiting. Still, yes, Sally. Right. So when you, if you know you have a seminar since the morning, එවනම් ගෙදරින් පොඩ්ඩක් කෑම ටිකක් හදාගෙන ඉන්න, like bread එකකට පොඩ්ඩක් butter ටිකක් ගහලා සීනි ටිකක් දාගෙන හරි අරවනේ. Right? Don't spend much for that because you're already spending for your transport and your education, right? So එතකොට එළියෙන් කෑම ගන්න වියදම් කරන්න එපා. ලෝභකම චුට්ටක් පුරුදු වෙන්න කමක් නැහැ. In the beginning of your life, මේ පොඩ්ඩක් stingy උනාට අවුලක් නැහැ. ලෝභ උනාට අවුලක් නැහැ. Right? මම කියන දේ ඔයාලට තේරෙයි දැන් නෙවෙයි. අවුරුදු 10කින් වගේ. Right? Okay. Shall I erase the board? Shall we move to the next question? Online. Online Budala. Drop a message in the chat box quickly. Amna, Hafsa Huzair. Tawa Hafsa kene kitiyane. Hafsa Ramzi. Hafsa Huzair, I think it's a new student. Hafsa Ramzi. Abe online nikkena. Kavitma, Sheikha, Sharfa, Taib, Tarusha, Vidusha, Jadushant, Zahra, Zainab. Drop a message in the chat box quickly, guys. Shall we move to the next part? Fine with this? Okay, right. Next one. ඊළඟ එක තමයි වැදගත්ම එක. Listen very carefully. Next one එක එන්න පුළුවන්. Now double modulus එකක් done. Types of other types also I discussed. Plotting the graph, right? Now when it comes to plotting the graph, still inequality solving part එක කරේ නෑ. ඒකේ types I will be discussing separately, right? When it comes to plotting the graph, the last type of the modulus graph that you can get is double modulus. So what happens to the triple modulus? Right? Double modulus එකක් තියෙනවා. Here see 6 question number 6. 6. Question number 6. Y equals to modulus of x plus 1. This is what I give. Then Buddha, listen very carefully. If I am taking, I take like this. This is y equals to fx equals to modulus of x plus 1. So I'm taking gx equals to modulus of x plus 1. Inside part, outside we have a modulus. Keep it aside for a while. I'll take this gx. This one is a small thing. We can define this nicely. And gx modulus of x plus 1. How do you define this one? Modulus is for x. X is greater than or equals to 1, greater than or equals to 0. Then we get x positive plus 1. If x is negative, minus x plus 1. Now let's plot this one. Here we have two graphs. Y equals to gx equals to x plus 1 is one graph for x is greater than or equals to 0 region. ඊට පස්සේ දෙනවා y equals to gx equals to minus x plus 1. This x is less than 0 region. Right? When x equals to 0, we get y equals to 1. When x equals to 1, we get y equals to 2. When x equals to 2, we get y equals to 3. Metana? When x equals to 0, y equals to 1. When x equals to minus 1, y is equals to 2. Right? Minus 2. When x is equals to minus 2, y is equals to 3. Right. If I plot this graph's function, it's a functions graph, functions graph. You see? Listen, don't write anything, listen. අහන් ඉන්න. Sorry. Yeah, මං ඒකට එන්න මං ඒක explain කරන්න තමයි I took this example. But මේකේ එන හැටියට wait. Minus. y එකේ plus පැත්තමනේ බං එන්නේ මට. එතකොට I can't even the modulus එක consider කරත් the same thing. I will change the question. පොඩ්ඩක් question එක change කරන්නම් පුතා because otherwise I can't show you what I wanted to show you in this. The make a, if I do like this, whatever the answer I get from this part will be the same answer when you consider double modulus also. So I can't show you what's the situation I actually wanted to explain here. ඒක මට පෙන්න ගන්න බෑ. So I will change the question to y equals to modulus of x minus 2 කියලා ගන්නකො. Take this as minus 2 plus 1 ගන්න නැතුව take this as minus 2. So this is going to be minus 2. This is going to be minus 2. This is going to be minus 2. So එතකොට මෙතන තියෙනවා y equals to x minus 2. Coordinates changes. මෙතනත් minus x minus 2. Right, coordinates change වෙනවා. Right. I wanted to show you a very important idea and the idea එක දෙන්න බැරි වුණා. I can't give that idea from the other one. Sir, that's my mother. Okay, you are joining from 2 devices. අනේ බං කලින් එහෙනම් rename with your name. I thought it's another student කියලා. You. If you are joining for 2 devices, then make sure to rename with your name again. Na? මේ ළමයි නම් අයියෝ. Right. When x is equals to here, margin is 0. When x is equals to 0, we get y is equals to minus 2. When x is equals to greater than 0 region of 1, when x is equals to 1, y is equals to minus 1. When x is equals to 2, y is equals to 0. And it goes on, right? Now, when x is equals to 0, y is equals to minus 2. When x is equals to minus 1, y is equals to minus into minus plus, plus 1 minus 2 is equals to minus 1. When x is equals to minus 2, y is equals to 0. Now here see, x-axis, y-axis, origin. Listen now. කලබල වෙන්න එපා. Still there is another modulus. I still didn't consider that. මම එළියෙන් ඉන්න modulus එක තාම ගත්තේ නැහැ. I'm still putting the inside one. Right, listen now. Now, when x equals to 0, y is equals to minus 2. Minus 1, minus 2. When x is equals to 1, y is equals to minus 1. Right, when x is equals to 2, y is equals to 0. So this one is valid for x is greater than or equals to 0 region. This is this is y equals to x minus 2. X minus 2. Now, when x equals to 0, y equals to minus 2. When x equals to minus 1, y equals to minus 1. Right? And then when x equals to minus 2, y is equals to 0. Minus 2, y is equals to minus 1. So this is y equals to minus x minus 2. Always remember to mark the piecewise function pieces. Now the thing is, what did we just plot? We plotted y equals to gx. But what we need to plot y equals to fx. May තියෙන්නේ y equals to gx පුතා. We just plotted y equals to gx. What is y equals to fx? Y equals to gx is what we plotted here, right? We need y equals to fx. fx කියන්නේ කවුද? This gx's modulus, no මුගේ modulus එක. This one's modulus. What is the modulus? If 5's absolute value is 5, minus 5 absolute value is also 5. What's the idea? Modulus says to return the magnitude, basically returns the positive. Returns the magnitude, basically returns the positive. එහෙනම්, if I'm applying the modulus for this graph again, plus ones plus money, it doesn't make any change. Again, my plus part is not going to make any difference. This plus part is not going to make any change. But what happens to this minus part? These minus parts, modulus එක ආය දාද්දී plus වෙලා උඩට එනවා. Okay, so final graph is going to be here minus 2, මේ පැත්තේ plus 2 වෙලා here this part is not touch the minus 2, එහෙනම් මේක not going to touch the minus plus 2. This part is going to touch this part. එහෙනම් මේක නෙවෙයි graph එක. Final graph is going to be this dotted ones mean that is not there කියන එක. This W is our y equals to modulus of x modulus minus 2 graph. මෙන්න මේ complete එක. This entire thing, this complete thing, I just put the arrowhead like this. This complete thing, all of them, right? එතකොට how about this straight line? Minus x minus 2's plus side. ඒ කියන්නේ මුගේ opposite එක නෙමෙයි. Right? This is minus x minus 2. That one's opposite. So this is y equals to plus x plus 2. This is plus x minus 2's opposite. ඒ කියන්නේ y equals to minus x plus 2. Y equals to minus x plus 2. This is what we get when we get a double modulus. May question in 2022 paper එක අහලා තියෙනවා. So all types of modulus graphs you can get. We did. Still we didn't discuss the modulus inequalities yet. Understand and quickly complete it. Quickly complete it. Online students, throw message in the chat box. Fine with that, clear with that. I need individual responses. I need individual responses quickly. Right, හරි නේද? You guys fine, clear? Imtas? Right, complete it. Either. No. X is the only one that changes. X modulus එකති. Right. Alright. Now write the next topic, solutions for modulus inequalities. Now, ඊට කලින් අපි මේ කෑල්ල කරලා ඉමුකෝ. Solutions for modulus equations. That part is not in the tute. Tute එකේ දාලා නැහැ. So write it separately. Second graph for what, Sharfa? This one. The second graph is the modulus. Modulus means the positive of it. Original one, here this gx part, the one inside this, that one only we plotted first. We are considering the modulus of it. Modulus of something means we are considering all positive conditions. This is the negative side. This is the negative side. Negative parts becomes positive when we consider the modulus of the original one. Positive parts won't change. No? Positive parts negative take a positive way. No? That's how this negative part came up. So these dotted parts won't come. Okay. Right. Now write the topic. Solutions for modulus equations. Solutions for modulus equations. Modulus equations karala dekak vitara karamu ege, and then after that we'll do modulus inequalities also. Shall I erase the board? Solutions for modulus equations. Shall I erase the board? Guys, drop a message in the chat box. Right, I'll erase the board. Right. Right. Try the first example question. Solve modulus of x minus 1 equals to 2. Solve modulus of x minus 1 equals to 2. Right. When we solve modulus equations, we can plot the graphs of both. You see, go to the trigonometry idea. In trigonometry, before we start discussing about the sine curves or trigonometric graphs, I told you when it comes to solving an equation using graphs, what's the idea? Taking the left hand side as one equation and the right hand side as another equation and solving it. So when it comes to equations, there are multiple ways. You can plot the graphs and solve, or else you can just take a set of simultaneous equations and solve. That is also possible. Since we need to get the graph idea to do the next part of the lesson, I will go with graphs only. Okay. So the idea is taking the left hand side of the function as one expression. I mean, left hand side of the equation as one function, right hand side as another function. I'll make a fx. I'll take this as gx. What's the idea? If we want to solve an equation using graphs, taking one side as one function, the other side as another function, and plotting the graphs of both functions on the same Cartesian plane, it will give us the intersection point x coordinates are the solutions. No? So if I take y equals to fx equals to modulus of x minus 1. This one, when x minus 1 is greater than or equals to 0, it gives you x minus 1 positive. When x minus 1 is negative, it gives you minus times x minus 1. So if I define further, y is equals to fx equals to modulus x minus 1, x minus 1, x is greater than or equals to 1, minus x plus 1, x is less than plus 1. So we have two graphs, y equals to x minus 1, which is defined for x is greater than or equals to 1. We have y equals to minus x plus 1, which is defined for x is less than 1 region. Take the coordinates. When x equals to 1, y is equals to 0. When x equals to 2, y is equals to, here the 2 minus 1 is equals to 1. When x equals to 3, y is equals to 2. When x is equals to 1, we get y equals to 0. When x equals to minus 1, minus and minus plus, 1 plus 1 is equals to 2, y equals to 2. Yeah, y equals to 2, 0 when x equals to 0, y equals to 1, when x equals to minus 1, y is equals to 2. Right, so x is less than 1 region. So let's plot that. X, y, origin, hare. So when x equals to 1, y is equals to 0. When x equals to 2, y is equals to 1. When x equals to 3, y is equals to 2. So this is y equals to x minus 1. Right. When x equals to 1, y is equals to 0. When x equals to 0, y is equals to 1. When x equals to minus 1, y is equals to 2. Here we have another function. This is y equals to minus x plus 1. Right. So what did we plot? We plot y equals to fx equals to modulus of x minus 1 එක තමයි ඔය plot කරේ. These two together. Right. Next, gx equals to 2. We have to plot the next graph also on the same Cartesian plane. This is gx equals to 2, no? Y equals to gx equals to 2. What is it? The straight line goes through what? 2 of the y-axis parallel to the x-axis. Intersection point x coordinates are the solutions. The method, since we have taken according to a scale, you get it. Sometimes you might not get a value that is known. You have to calculate and get it. Now, method solutions when x equals to 3 is one solution, x equals to minus 1 is another solution. That one, by looking at the here, I can say exactly intersecting at these 2 points. Let's say I don't know those points. We'll name the points as A and B, A point and B point. I'm going to solve at A point and solve at B point to get the answers. So we have y equals to 2 here. How to solve? These are an intersection point of 2 straight lines. How to calculate the intersection point coordinates of a 2 straight line? Solving the pair of solving the equations of the straight lines as a pair of simultaneous equations. We discussed that one in graphs. I mean graphs, straight lines. So when y is equals to 2 is one equation of this one. What is this straight line? Y equals to minus x plus 1. At this point here, see, at the intersection point, can you see both of them are having the same y value too? So at the intersection point, y is same. Then 2 equals to minus x plus 1. From here, we get x equals to minus 1. Simplify and get the x value, minus 1. Here, from the without calculating, we can understand because this is a known example. Nikang hari danne nattang, this is how you have to solve. consider the equations. Y is equal, so main right hand side equal. Solve करने दें. Here this is y equals to 2 graph, and what's the other graph intersecting? Y equals to x minus 1. At the intersection point, y values are equal, so therefore x minus 1 is equals to 2, x equals to 3. See, these are the solutions. And oh my god, right? Okay, so get the idea and try to solve this. Second one, solve modulus of 2x minus 1 equals to modulus of x minus 2. Modulus of 2x minus 1 equals to modulus of x minus 2. Solve. This is an equation, so you will get x equals to killer values in it. When it comes to an inequality, we get a range of values for x. We get a range of values for x. Right. Karinian. Right. Okay. I'll discuss that question. Right. Shall I erase this side, online students? Shall I erase this part? Online students, shall I erase this side? May part quickly. Right. Okay. Good. Great. Right. Now they want us to solve. Now stop working and listen. Y equals to, sorry, they want us to solve modulus of 2x minus 1 equals to modulus of x minus 2. So I'll take this as fx function, take this as gx function. These are both of them are modulus functions. Then I'll have to plug the graph of both modulus functions on the same Cartesian plane. When 2x minus 1 is greater than or equal to 0, we get 2x minus 1 positive. When 2x minus 1 is less than 0, we get minus times 2x minus 1, which is minus 2x plus 1. Right? For the entire part, we have the modulus. I think that classroom is closed. Go from here. Right? So fx is equal to modulus of 2x minus 1. 2x minus 1 is valid for x is greater than or equals to plus half. Minus 2x plus 1 is valid for when x is less than half. Right? Now, let's define the other one also before we plot. Anit ekak define කරලා එමුමු. Right. Gx is equals to modulus of x minus 2. Define it. When x minus 2 is greater than or equals to 0, we get x minus 2 positive. When x minus 2 is negative, less than or equals to 0, minus times x minus 2, which is minus x plus 2. So you get gx modulus of x minus 2, x minus 2, x is greater than or equals to 2, minus x plus 2, minus x plus 2, x is less than 2. Right. So we have four functions, no? Here see, y equals to 2x minus 1 is one, y equals to minus 2x plus 1 is another one. This one is valid for the region x is greater than or equals to half. This one is valid for the region when x is less than half. Method y equals to x minus 2 where x is greater than or equals to 2, and y is equals to minus x plus 2 where x is less than 2. Right. කම්මැලි වෙන්න එපා. Compared to you මට තමා අමාරු. දැන් ඔයාලට Monday batch එකට නම් ආයේ හවසත් class තියෙනවා. But still after this class, sometimes if you don't have a class, you are free no පුතා. So පොඩ්ඩක් කට්ට කාලා කරන්න මේක කරන්න දෙයක් නැහැ. අමාරුයි. combine maths කරන්න ආව නම් බඩ ගොඩයි. Right? දැන් මේ එක ළමයි මට කියනවා මේ සමහරුන් කියනවා මගේ වැඩ වැඩිලු කරන්න දෙයක් නැහැ. Workload එක වැඩි වුණාට කරන්න දෙයක් නැහැ. This is how you have to do it. මීට වඩා වැඩ set වෙනවා once the paper classes start. Right? Paper class වලට weekly one paper will be discussed in the class and a homework paper දෙකක් එනවා. Right? So පන්තිය කරන whatever the paper that we discuss in the class ඒකෙම replica paper එකක් එනවා, some different numbers and notations but same paper standard එකෙන් ගෙදර try කරන්න තව paper එකක්. So within a week 2 papers, but that homework paper marking scheme only provided because the similar paper discussed in the class, no, so no need to discuss the same kind of paper again. It's just for your evaluation. Right? ගෙදර ගිහිල්ලා තනියෙන් ආයෙ තව paper එකක් try කරන්න. Right? Paper class time එක දාන්න තමයි තියෙන ලොකුම ප්‍රශ්නේ, probably on Wednesdays night. Right? Wednesdays night Monday night can't take because Monday 27 ALL physical batch is here. Tuesday night paper class we can't take because Tuesday morning 26 revision and after 4 p.m. can't take a paper class now. 7:30 I have the 26 A level pure theory class. Wednesday 3:30 to 7:30 28 A level batch class is about to come. So එතකොට ඔයාලගේ paper class එක වැටෙන්නේ Wednesday 8 p.m. onwards. Thursdays I'm not going to take for the paper classes because Thursdays dedicatedly I kept it for 26 A level batch. Doubt clear කරන්නයි යොන්ගේ seminars දාන්නයි mixed exercise sessions for 26 A level batch එකට තියලා තියෙන දවස තමයි Thursday. Friday 26 A level batch paper class is finishing at 7:30. Friday I can take, but we'll see. Friday Wednesday night or Friday night, one of those 2 days I'll be keeping the paper classes. Sometimes one of those 2 days I will do the live class, in another day repeat recording එකක් ඔයාලට යන විදිහට හදලා දෙන්න. So those who can come on Wednesday can come and join the live. Friday others can go through the recordings. Or Friday live කරලා මෙතන recording Wednesday වලට recording දෙන්නත් පුළුවන්. I still haven't decided it. Saturday night 27 A level online batch. Sunday night can't take because දෙමට කොට 27 A level එක ඉවර වෙලා ගෙදර යද්දි ආයෙ මට කරන්න වෙලාවක් නැහැ. And all those students also won't be able to join. So Wednesday and Friday are the 2 only possible days that I have for the paper classes, right? So try karla join venna because benefit is for you only, yeah? Right, when x equals to half, when x equals to half, we get y equals to 0. When x equals to 1, y is also equals to 1. 2 coordinates enough actually. ඕන තව එකක් ගන්න when x equals to 2, y is equals to 3. Right. So when x equals to half, මෙතනත් y is equals to 0. Less than half means when x equals to 0, y is equals to 1. 2 coordinates enough. When x equals to 2, y is equals to 0. When x equals to 3, y is equals to 1. Okay. When x equals to 2, y is equals to 0. When x equals to 1, y is equals to 1. Right? එකම coordinates නේ බං එන්නේ. But that is 0, 0, 1. Gradient is different, no? So I think we need another coordinate to properly identify the situation. Right. I'll take a different another coordinate when x equals to 2, y is equals to 3. When x is equals to less than half, no, again x equals to -1, y is equals to minus into minus plus, right? When x equals to 2, make a y equals to හරිනේ තමයි simplifications. When x equals to half, y equals to 0. When x equals to 1, 2 times 1 is 2, 2 minus 1 is 1. When x equals to 2 times 2 is 4, 4 minus 1 is 3. But then x equals to half 0, when x equals to 0, 1, when x equals to -1, minus into minus plus, plus 2, plus 1, plus 3. Plus 3. So here also I'll take another coordinate when x equals to 4, y is equals to 2. When x is equals to less than 2, no, 0, y is equals to 2. Right. So I'll plot the graphs of both functions on the same Cartesian plane. X-axis, y-axis, origin. When x equals to half, then since I have to take half, I'll take 1 පොඩ්ඩක් ලොකුවට ගන්නම්, 2 and 3. Okay. Same -1, -2. When x is equals to half, it's exactly in the middle of this. Right? When x equals to half, y is equals to 0. Here we have a coordinate. When x is equals to 1, y is equals to 1. Here we have another coordinate. And then when x equals to 2, y is equals to 3. 2, 3. So we get this is y equals to, make sure at that time itself practice it to mark the straight line name 2x y equals to 2x minus 1 equation එක දාගන්න. That it's in the greater than or equals to half side, so this is correct region. Adana, when x equals to half, y equals to 0, when x equals to 0, y equals to 1, when x equals to minus 1, y is equals to 3. So we don't have the equal sign with a small gap, draw like this. This is y equals to minus 2x plus 1. Minus 2x plus 1. Now let's plot the other one. Maya, I'll plot that in a different color. I don't know whether for online students will it be visible or not. Balamu. When x equals to 2, y is equals to 0. When x equals to 2, y is equals to 0. When x equals to 3, y is equals to 1. When x equals to 3, y is equals to 1. I need more space on the other side. Okay. Then so quickly write this down. I will take this graph. This one's gradient is 1, no? 1 kilogram. This one gradient is 2. Okay. When x equals to 3, y is equals to 2. I'll just mark this. When x equals to 3, y is equals to 1, not 2. Y is equals to 1. Like this. Right? So, what is this graph? Y equals to x minus 2, okay? Y is equals to x minus 2. Now here see, this one's gradient is 1, this one's gradient is 2. So if you take a proper scale, gradient 2 එක මෙහෙම තියෙන්නේ. Gradient 1 එක මෙහෙම තියෙන්නේ. So if we extend it further and further, these two are not going to meet in that area. පල්ලෙහා පැත්තේ both of them are not defined, no? From bottom they will intersect, but that area is not defined because this one is defined for x is greater than or equals to 2 region. This one is defined for x is greater than or equals to half region. So these two are the only parts we can consider. And this one's gradient is 2, this one gradient is 1. So this one is going to go like this, this one is going to go like this. It's never going to intersect. Right? So hinda I don't have to I thought of erasing and drawing that again. I erase kalandinonne. Let's take the other part. When x equals to 2, y is equals to 0. When x equals to 1, y is equals to 1. Here we have coordinate. When x equals to 0, y equals to 2. Here we have another coordinate. Right? So I feel like it might be intersecting here. So I will, you take a proper scale and do it. When x equals to minus 1, y is equals to plus 3, no? When x equals to minus 1, y is equals to 3. In a method intersect in one. Right? So we get a graph like this. Make out the y equals to minus x plus 2. Let's say you don't know the intersection point coordinates. Assume that you don't know. If you know here, according to the skill, we can directly say x equals to minus 1 is one answer, x equals to 1 is another answer. Intersection point x coordinates, no? Other than that, we don't see any other intersection points. No? But the thing is, in case, let's say you don't know the coordinates, then what we do? Solving at A point and solving at B point. At A point, what are the graphs intersecting? Y equals to minus x plus 2 ekai, y equals to minus 2x plus 1 ekai. At the intersection point, y coordinate is same 3. X coordinate minus x plus 2 is equals to minus 2x plus 1. It's going to be minus 2x, take it to the other side, plus 2x minus x equals to x. Take plus 2 to the other side, minus 2, plus 1 minus 2 is minus 1. X equals to minus 1. How about this? Methana intersect වෙන්නේ y equals to minus x plus 2 graph, this one, and what's the other one intersecting? Methana, this one, no? 2x minus 1. At the intersection point, y value is same, so you can equal the left hand side. Minus x plus 2 is equals to 2x minus 1. So it will give you 3x is equals to 3, right? 3x equals to 3 kilogram. From here we get, I don't know whether it's okay, x equals to 3 kilogram. So sorry, x equals to 1, not 3, 1. Divide both sides by 3, x equals to 1. By solving also we get the same answers. Directly pay namana directly we can take. In future you won't get directly pay na, so I just solved it and showed it to you. Right. Okay. So to start the inequalities, modulus inequalities, and finding solutions for that, we don't have enough time. So next week in our seminar, instead of partial fractions, I'll be discussing the modulus inequalities and logarithms. Modulus inequalities ivara karala, and then we'll discuss the logarithms part. Okay, partial fractions we'll discuss in our December poya day එකේ තියෙන session එකේ we'll discuss it. Right. Today's session මෙතනින් wind up කරමු. Before that, online students, drop a message in the chat box. All good, understood. I need individual responses. Tag gala දාන්න බලන්න. So this week in all my batches, I'm starting the vectors for 27 A level batch. Trigonometry last part in the. Okay. So I think for Dematogoda batch, I already started vectors, right? For Sunday, Saturday online batch, we have an extra session coming Saturday morning. So AKD will be discussing vectors, right? So Monday batch, ඔයාලට අද තියෙනවා session එකක්, which is supposed to happen yesterday. We'll be having a session today. Okay, today I'll be starting vectors for you, right? So bring a new book. Okay, bring a new book to work on that. So එතකොට මේ මාස වෙද්දී trigonometry is done, vectors next month, second week, third week, the vectors utivara, and then I'll be starting the system of coplanar forces. Parallelly, the statistics and probability seminar series is happening. Please, all 27 A-level batch students join and complete that work. ඔයාලට එන්න බැරි නම් sir බෑස වගේ එකක් තියෙනවා නම් I can't force you, but I recommend you all to join, because if you cover it up early, it's a benefit for you. If you are not covering it up, next year also I'll be conducting statistics and probability seminar series. ඒකට join වෙලා අනිවාර්යෙන් කරගන්න ඕන, because if you miss that chance also, ඉතින් ඔයාලට කරගන්න වෙලාවක් නැහැ. But those who finish the statistics and probability early පුතා, then you are finishing the statistics and probability 18 months before the exam. 18 months before the exam means you have plenty of time to do the past papers and practice it. හරි? Past papers කරලා මගේ in my paper classes 27 A level batch paper class එකේ මම questions දානවා, because I asked you all to come. You didn't come, means it's not my fault, no. I'm finishing a part in the syllabus, means I have to discuss questions with the students from that part, right? Then in my paper classes I will be including statistics and probability questions, straight lines and circles questions, polynomials, quadratics, vectors, ඊට පස්සේ trigonometry, now modulus functions, කරපු ඔක්කොම පාඩම් වලින් questions paper class එකේ එනවා, right? So then work, today's session will wind up at that point. එහෙනම් වැඩ කරන්න ලෑස්ති වෙන්න. ඒකකට වැඩ ඒකක් නෙමෙයි, ලකුණු 100කට දැන් වැඩ කරන්න වෙලා තියෙනවා, right? So I need a small help. You will be able to send me the recording from the starting point of modulus functions. I was in recording will be sent not today. Once it is uploaded to the drive, I will let you know. YouTube upload karne ka I still haven't thought of it. Once I upload it to the drive, I will let you know. Okay, right? So then that's it for the day. You all can leave. We'll meet in our next session coming Thursday with the circles, right? Circles එකේ තව theory ටිකක් තියෙනවා, ඒකත් ඉවර කරමු. Thursday we'll meet. So then good luck. We'll meet in our next session. යන්න පුළුවන්. නමස්කාර.